O, bardzo dziękuję. No może tu. A szklankę. Ladies and gentlemen, would you please take your seats, please? I'm very sorry for this delay with starting this conference. We are waiting for the delegation of our Ministry of Science and Higher Education. Unfortunately, you might know that in Warsaw right now starts a huge demonstration of scientists, and everybody's on the street. So we fight for a better budget for science in Poland. So I may guess that all of them are at the moment starting this demonstration. So that's the reason why we have kind of a conflict of interest at this stage. But distinguished guests, please forgive me for not naming all distinguished guests that we have in the room. Dear colleagues, ladies and gentlemen, also very warm welcome to those joining us via live stream. It is great pleasure to welcome you all here today on behalf of ALLEA, the European Federation of Academies of Sciences and Humanities. My name is Paweł Rowiński. I am president of the Academy. We are together here with two of my vice presidents, Aneta Kieslich and Marie-Louise Bechnosch, who are with me, and they will jump in from time to time to help me with leading this meeting. And we are delighted to open this conference with such a distinguished and diverse group of participants representing academies, policy institutions, early career researchers and partners from across Europe and beyond. Let me begin by expressing our sincere gratitude to the Polish Academy of Sciences for hosting the 2026 ALLEA General Assembly here in Warsaw. We have Vice President of the Academy with us here. We are deeply thankful to your generosity, professionalism, and warm hospitality. Holding our General Assembly in Poland at this moment carries particular significance and reflects the strong engagement of the Polish academic community in shaping Europe's scientific future. I would also like to warmly thank the Copernicus Science Center, also the director of the center is with us, for hosting us in this inspiring venue. Being here in a place dedicated to science communication, public engagement, and dialogue between science and society provides a highly fitting setting for our discussions today. At a time when public trust in science is increasingly challenged, institutions like the Copernicus Science Center play a crucial role in making scientific knowledge accessible, fostering curiosity, and strengthening the relationship between science and society. In a moment, we will hear more about the center and its mission from its director. I would also like to pay your attention that we have a nice exhibition outside this room, exhibition about Warsaw. I would also like to add a more personal word of thanks to my home institution, the Institute of Geophysics of the Polish Academy of Sciences, for the strong engagement and organizational support in preparing this conference. And I am equally grateful, there are no representatives from the ministry, but to the Ministry of Science and Higher Education for its generous support and for providing a special grant that made the realization of this event possible. I am also pleased to acknowledge the co-organization of this conference with ALLEA, the European Network of Young Academies. This partnership highlights the importance we place on the intergenerational dialogue. Engaging early and mid-career researchers in science communication and public outreach is essential for sustaining public trust in science and for ensuring that our research communities remain open, inclusive, and responsive to societal needs. This conference takes place at a time when Europe is facing growing geopolitical, economic, and societal uncertainty. Across our continent, we see increasing pressures on academic freedom, institutional autonomy, public trust in science, and the resilience of research system. In this context, one message is clear. Academic freedom and institutional autonomy are preconditions for societal resilience, but they must be complemented by meaningful engagement with society. Strong, independent science can only fulfill its role if it is understood, trusted, and valued by the public. This is precisely where ALLEA sees its role. ALLEA brings together 61 academies. So far it was 60, but we are now a larger family, it is to be mentioned a bit later, from around 40 countries across the Council of Europe, region serving as a platform for dialogue across borders, disciplines, generations, and sectors. For decades, our federation has been committed not only to promoting research integrity, responsible conduct of research, evidence-informed policymaking, and the safeguarding of academic freedom, but also to strengthening trust between science and society through transparency, openness, and responsible communication. The discussions we are opening today are also firmly embedded in the current policy context. This conference builds on the G7 Academies Ottawa Declaration of 2025 and offers a timely contribution to ongoing debates surrounding the forthcoming European Research Area Act. If you want a future-proof European research area, it must be based on trust, integrity, openness, autonomy, and resilience, and it must actively invest in science communication as a core component of research system. Trust in science and trustworthy relationships cannot simply be expected, they must be nurtured and renewed. I hope today's discussions will also touch upon themes such as brain circulation and sustainable academic exchange, support for early career researchers, international solidarity, including with colleagues affected by war, and the role of science diplomacy in times of geopolitical tension, where credible and trusted scientific voices are more important than ever. This is worth mentioning yesterday, a satellite event that we had yesterday in Stashic's Palace on supporting the Ukrainian research ecosystem through international exchange and collaboration. Before we begin, just a brief practical note. We are pleased that today's event is being live streamed, allowing colleagues across Europe and beyond to join us. I will be also assisted throughout the conference by the new director of ALLEA, so let me introduce Tatiana Koenig, who is our new director, being with us here, who will help guide us through the housekeeping aspects of today's program. And with that, it is now my great pleasure to invite the Vice President of the Polish Academy of Sciences to say a few words to us. Thank you.
Honorable guests, or distinguished participants, ladies and gentlemen, it's my great pleasure to welcome you to this event on behalf of the Polish Academy of Sciences. This year, Polish Academy of Sciences celebrates its 75th anniversary. It was constituted during a very sad era of communism and went through very many turbulent periods. Let me just mention martial law of the 80s. Even so, from the very beginning, Polish Academy of Sciences established its independence. The independence from current policy and from the politicians. The independence in terms of undertaken activities and research conducted by the institutes of the Polish Academy of Sciences. The research has been always, and it is, at the cutting edge of the world's science. The independence of science is a milestone of modern societies. Today, we face serious threats to academic freedom as well as a range of challenges that create new barriers for science, and I can repeat it after Professor Rowinski. We are very pleased to host ALLEA Congress in Poland, today at Copernicus Center and tomorrow at the Staszic Palace, a historic venue of the Polish Academy of Sciences. Your presence here proves the importance of strengthening European scientific cooperation at a time when trust and integrity are more vital than ever. I am fully convinced that the academic community must act collectively, because only then its voice can be fully heard. I'm not in the position to summarize the history of links of the Polish Academy of Sciences and ALLEA. Let me just say that the Academy played an important role in the establishment of this federation in 1994. The preparatory work leading to the creation of ALLEA involved the active engagement of the former president of the Polish Academy of Sciences, Professor Aleksander Gejsztor, and was strongly supported by his followers, Professor Leszek Kuźnicki, Michał Kleiber, and of course, current president, Professor Marek Konarzewski. Over the years, this cooperation has translated into many joint activities and meetings. Researchers affiliated with the Polish Academy of Sciences actively contribute to ALLEA's work, including its working groups and the research ethics and integrity. Ladies and gentlemen, the subject of this conference could hardly be more timely. In current circumstances, the academic community must act collectively. I wish you a very fruitful meeting and pleasant stay in Warsaw. Thank you.
Thank you very much. We start to be very serious and official, so we can try to change into more loose atmosphere. But still, we have one welcome words from director of this Copernicus Science Center, Robbert Firmhofer. Robbert, please, the floor is yours.
Thank you. Let me be serious for another 3 minutes, please. Distinguished guests, ladies and gentlemen, it is a great honor and pleasure to welcome you to the Copernicus Science Center in Warsaw for the ALLEA General Assembly 2026. We are truly delighted that this important gathering of the European academic community is taking place here in a place dedicated to science, curiosity, dialogue, and public engagement. At Copernicus, we believe that science is not only a source of knowledge and technological progress, but also an essential part of the democratic culture and social resilience. In a world shaped by rapid technological change, environmental crisis, information overload, and growing social polarization, helping people understand science and build a meaningful relationship with it has become more important than ever. For this reason, the Copernicus Science Center is much more than a museum. We see ourselves as a public space for experiencing science in many different ways, through exhibitions, planetarium shows, laboratories, educational programs, artistic activities, debates, citizen science initiatives, and direct encounters with researchers. Every year, more than 1 million visitors come to our center here in Warsaw. Through nationwide networks such as SOWA, Young Explorers Clubs, and ESERO Poland, developed in partnership with the European Space Agency, we engage an additional 500,000 people across the country, bringing science engagement and inquiry-based learning to communities far beyond major urban centers. At the same time, Copernicus conducts interdisciplinary research and development activities focused on science learning and public engagement with science. We develop and test new educational methods, formats, and tools, always in close collaboration with educators, researchers, and social partners. Particularly today, we attach great importance to building trust in science and scientists. We aim to achieve this not through one-way communication, but through participation, dialogue, and shared experience. Citizen science projects, encounters with researchers, public discussions, and collaborative activities all help create meaningful relationship between science and society. This mission would not be possible without our close and long-standing cooperation with academia, and notably the Polish Academy of Sciences, whose scientific expertise and intellectual partnership play an essential role in development and delivery of our programs and activities. We are proud of this collaboration and deeply value its quality and ambition. Our work has also a strong European dimension. As an active member of EXCITE, the European Network of Science Centers and Museums, we are committed to shaping the future of science engagement in Europe together with our partners across the continent. Ladies and gentlemen, I wish you a very inspiring, productive, and fruitful General Assembly. May your discussion here in Warsaw contribute not only to the advancement of European science, but also to strengthening the relationship between science and society across Europe. Thank you very much, and welcome to the Copernicus Science Center.
Ladies and gentlemen, Professor Robbert Dijkgraaf is a distinguished mathematical physicist and academic leader. He is a distinguished university professor at the University of Amsterdam and the president-elect of the International Science Council. Before that, he served 10 years as director of the Institute of Advanced Studies in Princeton. He's also served as Minister of Education, Culture and Science in the Netherlands. Dijkgraaf's research focuses on the interface between theoretical physics and mathematics, and he has contributed to very different fields such as the understanding of string theory, black holes, and the topological field theories. He's also an experienced public policy advisor, having served as president of the Royal Netherlands Academy of Arts and Sciences and of the Inter-Academy Partnership. And importantly, he's also very kind and generous with his time. In 2025, you are cited for saying, and I quote, "Especially in these times of geopolitical tension and global challenges, it is important that the voice of science rings clear and that researchers continue to engage in dialogue with each other and with society at large." But what is the voice of science? Let's listen to your voice now.
Dear colleagues, thank you so much for that kind introduction. A great pleasure to be among you. And indeed, my theme will be the important role that academies can play. Now, the International Science Council is the oldest and most comprehensive organization representing the global science. I think all of your countries and most of your academies are a member, including the Polish Academy of Science and the Polish Young Academy. You might belong to professional organizations. Many of the international unions are members, young academies. But if you look back at the very beginning of the International Science Council, which was in the late 19th century, where a group of academies, large academies, European, but also the American Academy, came together, and they argued that often it was remarked, scientific contacts precede economic and political ones. And so it's important to do this, quote, even though the weather was clouded. And I think in some sense we are very much in the same position as our colleagues in the past, and I hope we can get some inspiration from that. Actually, I want to begin by saying a few words about where we are in science. And I like to quote here someone who you will not expect me to quote, which is Leonid Brezhnev. He was once asked would he could summarize the state of the Soviet Union in one word. And his answer was good. And then he was asked, what about if he could use 2 words? And his answer was, not good. In no way I'm comparing the state of science to that of the Soviet Union, but I want to talk about the good before I talk about the not good. So what is the good? I think we should be all very excited that we live in a time of accelerating scientific progress. I like to phrase it that there are unprecedented opportunities, we have new insights, we have new methods, we have new technologies. In many ways, I think it's the best time to be a scientist. And actually, this was probably also true in the past. You know, we are in a growing field, and in every time, there are unprecedented opportunities. The way you like to phrase it, actually, is that we're going through a major transition. I like to say that the 20th century was about discovering the building blocks of reality. The genes, the proteins, the DNA, all of it that is the basis of the life sciences. In material science and matter, it's the particles, it's the atoms, the molecules. And in information, it's the bits, it's the algorithm, it's the networks. And now we are in the next phase, which is what can we build out of these building blocks? So indeed, it's a time of genetic editing, of artificial life, of quantum and nanomaterials, where you can arrange matter atom by atom. And of course, artificial intelligence, deep learning, and everything that we see around us. And in some sense, you can say that where in the past we were discovering the world around us, now we're creating the world. And that's a much vaster space to investigate than before. So unprecedented opportunities. And in fact, all these technologies reinforce each other. Perhaps one of the key applications of AI is new materials that again build, new drugs or new therapies. And some people say that, particularly if you look at the applications of AI for science, that some elements of the scientific discovery process are radically accelerating, a factor 10 or a factor of 100 perhaps. So that means in some sense, if you wonder what the end of this century will bring, we probably all will live through it. So that's extremely exciting. On top of that, I think we never had so many people joined the global scientific enterprise, including many from regions, from social strata that were historically excluded. A much more balanced participation in the scientific enterprise. And this is getting very exciting. It's of course very sad that in the past, huge parts of the world were not included in science. And then I think, on top of that, modern communication methods make this community into a true community. We never actually were so coherent in our collective behavior. Just a few graphs to show this. This is the growth of scientific publications. We can argue whether that's a good measure, but certainly you see that parts of the world are lighting up. It's not only Europe and the US, and we see a tremendous increase in other parts of the world. I also like this map. This is not from my in-flight magazine, but it's, I think, a beautiful realization of the matters of scientific collaborations around the world. And you see how intimately we are connected, and we'll speak more about Europe, but you see it's certainly a global hub in this huge network that we have shaped in the past decades. So these are all remarkable achievements. And on top of that, I think, from my own experience in government, there is not a single policy issue, ranging from agriculture to migration, to energy to security, where science is not needed to inform policy decisions. And again, it's an easy prediction that in the future, all policy domains will be more influenced by science and technology. We'll come back to how we deal with that, but that's certainly giving. And then finally, I would say that the real problems that the world is facing, the global societal challenges, whether it's about the climate, pandemics, food, you name it, the regulation of technology, science plays an incredibly important role. So in some sense, I think that's the imperative to have a strong scientific base and to work globally, collectively together is more powerful than ever. So much for the good. Now to the not good. As already was mentioned in the introduction, science is under pressure. We have to be realistic, and particularly the geopolitical climate, as it was in the late 19th century, is clouded. As already was mentioned, academic freedom is under pressure. We see this in many possible ways. We see this, in physical threats, in online threats. And it's good, perhaps, to make the distinction, as the philosopher Isaiah Berlin made, between negative freedom and positive freedom. So negative freedom is the absence of threats. And here we have to see that there's a rather exponential growth in the pressures put on scientists. Some reports show that roughly half of all the climate scientists and half of all the virologists during the pandemic had some form of threat, online or physical one. But then there is the positive academic freedom. Do you have the opportunities to actually explore what you want to explore? And here we see again, in many countries, national government funding agencies have a kind of a narrow view. There's some shapes of censorship. It's a much more constrained view of what the future of science is. We also see well-organized, I would say, global disinformation campaigns. Often, by the way, disguised as as real science. Some of you have seen the kind of fake IPCC report. It looks very impressive. Even the typography is very similar. And that actually is eroding many of the consensus. And I would say, in the end, what's eroding is our shared experience of empirical reality. It's big words to use, but I think the scientific community is also speaking on behalf of an important stakeholder in all of this, which is reality itself. And then we see governments having kind of a short-term focus. I will come back to it, but a lot of these discussions are about economic growth, about strategic autonomy, about national security. And obviously, if you look through that lens at science and research, you have certain areas are more prominent than others. One thing I particularly worry about is the decreased emphasis, and I would say the marginalization of the humanities and the social sciences. They're absolutely crucial in our understanding of our position in the world, but also understanding how these tremendous scientific and technological progress actually is interacting with society. Well, one of the wonderful things would be a theme during my talk is all the great questions that we can ask are actually good research questions. All of them, actually, there are scientists who study all those issues. And the self-reflective property of science, of the sciences in a broad sense, is an incredible, powerful strength of what we do. But also the multilateral system itself is under strain. Actually, diplomacy itself is under a lot of pressure. Now, sometimes if people ask me, what is the International Science Council? I say, well, it's something of the UN of science. And then people look at me and say, I hope not. And that actually is my one-line summary of the state of global scientific collaboration. So the UN and its agencies, and as I said, diplomacy itself, are weakened, by some countries even actively undermined. It's a very polarized geopolitical climate. You've seen, for instance, quite dramatically the withdrawal of the United States from many of the UN agencies, including the World Health Organization, the Meteorological Organization, UNESCO, the IPCC, the climate framework. So these are all the structures we have built over many, many decades to coordinate global scientific response. And I think we all agree there's need of more coordination. In fact, I think, it's quite remarkable that the global challenges, like the Sustainable Development Goals, of the issue of technology regulations, in the eye of many now, are seen as a threat to economic progress, to political autonomy, to unconstrained industrial development. If you want to amuse yourself, there's the Optimist Manifesto. It's something that circulates in Silicon Valley. And actually, the SDGs and multilateralism are seen as, and the precautionary principle are seen as the enemy. And in fact, it's kind of an interesting situation because that criticism, on the one hand, scientists is accused of being weakened, but also we are accused of wanting kind of world government that regulates some issues. And I think not entirely wrong. I think, this, from a scientific perspective, there's a strong case to make that certain things have to be better regulated. I think actually the lack of trust in the multilateral system in the global south is in some sense more authentic and more perhaps can be argued more rigorously because there's a lot of loss of patience with particularly the industrialized nations that the access to science globally, the burden of the global challenges is very unevenly distributed. And so I think there's another big challenge for all of us. Is there truth in advertising? Does science indeed is able to solve those global challenges and be there also from the countries that, in some sense, are in the most vulnerable position? But I would say, and I come back to this, all these challenges provide also opportunities. And I think particularly Europe has an incredibly important role to play because I think it has a position right now that is very sympathetic to many of those issues and can really play a much more forceful and proactive role. So a few words, why is this happening? So in an ironic way, some of it is because of the success of science. I think, much of this political backlash is due to the growing impact of research. In fact, if you see what are the areas that are most controversial and where you see the most pushback, it's often issues like climate science, about public health, about technology regulation, which exactly are the issues where science has the biggest impact. So I like to joke, it's something like Newton's third law, like action is reaction. Science pushes society, and parts of society are pushing back. That also tells us that this is something that might stay with us, because as I said, it's an easy prediction that the impact of science in general on society will only be bigger. And so how do we deal with this kind of backlash, and how do we organize ourselves in that respect? Also, what we see is that science and politics are much more entangled. The interface between science and policy and interface between science and politics is increasing. This is famous saying, if you mix science with politics, then you get politics. I think that's a bit too easy, but there is a challenge how we kind of navigate that interface between science and the rest of society. So when I joined the Dutch government, there was this cartoon in the Dutch newspaper I like to show. You see me here descending from an ivory tower on a small planet called Princeton into something which you might recognize as a big black hole, which is my field of study, labeled politics. And that already tells you in some sense often, by the way, this is in general, I think, the perception among scientists, that you're descending into something and you're lowering yourself to be involved in political issues. And if you look at the standing of professions around the world, and this is actually true across the globe, you see that scientists are still at the very, very top in professions that have public trust. By the way, scientists often, I think it's often called the medical scientists that even trust it a little bit more, and even those that are close to people. But you see politicians and government ministers are at the very, very bottom. So if we talk about the interaction between these two worlds, you know, we have to organize, well, it's not really a black hole, but these are two worlds that are very, very much complementary and have a different point of view and different ways to look at the world. You know, to be a bit like a character, but science is international. Politics is by definition national. We believe in a kind of win-win. You know, if one of my colleagues has a terrific result, then I will benefit. In politics, it's a zero-sum game. You know, the number of votes add up to 100%. We are very rational. Politics are often very emotional. We want to make things very precise. If in politics you put something very, very precise, it's completely useless because you need some kind of ambiguity. But perhaps most important, if we talk about our issues, we do it from a positive point of view. It's well documented by social scientists that in politics, if you discuss, the longer you discuss a certain topic, the more negative the people think about it. And you see this is a very, often by certain political circles used very effectively. Just addressing topics, I think in many countries it's a topic of migration, you know, where you keep on circling around it and create a negative feelings. While we think of problems as something wonderful, I have a colleague in Princeton who has a little sign on his wall and says, he's a mathematician, and it says, math is such a drama queen, she can impossibly have so many problems. And I think, you know, one thing that is changing, and that's why I think we need to discuss the relation between science and society, is what's kind of happening is that science is kind of penetrating, is infiltrating the world, our lives, society, in more and more in small bits. And so science is no longer something that only is there behind the high walls of laboratories and universities, but it's like almost like a fractal, it's all over in society. And so the interface that you want to navigate between science and society, or science and policy of politics, is a very long and complicated and moving border that we'll probably will have to spend much more time in controlling that, in spending time in how we cross that border, how we have our interactions along that frontier. And finally, I think what we see, and that's perhaps the most worrying thing, we see kind of polarization of institutions. Well, as I said, scientists are still among the most trusted in society. But if you look in more detail among trust in society, you see actually that large part of society is gaining trust in science. Another part is losing trust. And actually the fault lines in society are more and more across educational lines. And this is a tremendous problem for the academic world. If in the end, only people who have attended university or are intimately connected with research appreciate science, have trust in science, then we do a really bad job. We see this around the world. It's very worrisome. Just to mention one fact that I was really shocked to read recently, this was about the United States, where if you look at the feelings of some of those prestige research universities, the most negative feelings were people living right across the street, on the other side of the campus, who simply didn't see the value of those institutions. So I think this is something that we have to address. Another topic I think that makes our lives more complicated is what's usually called the securitization or even the weaponization of science. And we see this actually as is one of the main reasons why there are rising barriers to international cooperation. Now it's increasingly, as I said, the main stage for economic competitiveness. It plays an important role in national defense and security. And we are moving in a situation where technology becomes incredibly powerful, but it's almost impossible to point to a powerful technology that does not have dual use aspects. And how do we deal with that? That's a completely new world. We see actually here in Europe vast increases in research in defense spending, and also promises that large part of that new money will be spent on research and development. If you think about in the European context, we moved to a NATO norm of 3.5% of GDP. I think there's some goal of spending at least 10% of that in R&D. So in many countries, there will be tremendous amount of defense or security-related defense expenditures, and are institutions, universities, research funders in a position to deal with that? And as I said, you know, it's increasingly international scientific cooperation is also seen through this lens. And that actually gives a lot of paradoxes. You know, you see that in some sense, the more science matters, the more it's become, international cooperation has become a threat. And I think we see this in many countries. We see visa restrictions, we see increased security protocols, even of, I would say, kind of standard scientific corporations. Universities treating this openness as also as a vulnerability. And again, I think this is an issue that's moving fast, that we are kind of finding our ways around. I actually want to show, this is a picture of my old office in Princeton. This is the most famous inhabitant of that office, Oppenheimer. And I often thought, well, when I was in that office, that when he was there, in front of the office, there would be a huge safe with 2 US Marines guarding the safe. So just think of that. You walk into your office and there are two soldiers clearly aware that the elementary particles that he was studying could be used you know, in dual use. And of course, he's very much somebody associated. This is the picture of the Institute for Advanced Study in Princeton around the 1950s. And why I'm showing this, that you know, it's a relatively small building, but it had quite famous inhabitants. So this is the floor plan around that time. So these are 3 famous inhabitants. So, and I want to kind of position them because there are, I would say, 3 different approaches to these kind of issues of national security. So on the left, of course, is Albert Einstein, although he was instrumental in starting the nuclear program. By that time, in the 1950s, he was seen, of course, as the father of the peace movement, had very strong views about disarmament, with Bertrand Russell, founded the Pugwash Conference, etc. The second is John von Neumann, famous mathematician, the coldest of cold warrior. You know, there is a famous story told about him, which is true, that he was asked, Professor von Neumann, do you feel that the United States should start bombing the Soviet Union tomorrow? And his answer was no, this afternoon. You know, his game theory led to the first strike. And the third one, of course, Oppenheimer, that had a very complicated position, where in some sense, you know, he was criticized from both ends. He was both a communist and a war criminal. And it's kind of remarkable that both Einstein and von Neumann have like unproblematic public profiles, while the one that was trying to walk this kind of middle path is at least seen as problematic. Of course, now he is a movie star, but that's kind of a surprise. And I'm describing these 3 scenarios because it's the way I frame many of these issues, particularly around security. So I like to say, you know, we're walking along this very kind of narrow path, actually running because things are going very rapidly. And there are 2 cliffs that, you know, the scientific enterprise can fall off. One is to be paranoid and just stop collaboration. And the other one is be naive. So I like to joke that, you know, governments are by definition paranoid, scientists perhaps by definition naive, but actually the truth is, I tell from experience, that governments are largely paranoid about scientists being naive. That's their biggest worry. And so there's an important role for scientists to tell governments that they're not naive and they understand what's going on, but to defend their values. And I think that will be another theme in my lecture. We have fundamental values, and it's very important that we protect them, that we frame them, and that we make clear that we're not naive in believing those values. But I think, it is problematic that these days international collaborations are seen through this very specific lens. And I would recommend that if we think about research security or international collaboration, we do at least some kind of triage where we divide our arguments or our relations in three buckets. The first one is there are many issues where collaboration makes real sense. Obviously, in global challenges, we need to collaborate. It is remarkable right now, we're living at a time when we discuss the great commons on the planet, whether it's the oceans, whether it's the Arctic, whether it's space, that we basically at a time where we never had so few data because we're no longer sharing the data. I was talking to somebody who's an experienced Arctic researcher. He said, no, I have less collaboration now than I had in the 1960s. A second theme where we really can collaborate is in the basic science. But to come back on the global challenges, here there's an important mission, I think, for the scientific community to make clear to our governments, to our institutions, that it's in the self-interest of nations to collaborate. If you want to know where the next pandemic is coming from, most likely not from your country. If you want to see what the next threat is, whether it's a weather phenomena or an ocean phenomena or a climate phenomena, it's probably originated somewhere else on the world. So there's a great need to share those data just for your own kind of national safety. The second theme is basic science. We'll come back to it. But there are many areas where it totally makes sense to be in a win-win situation, to share data, to share insights from around the globe. And a particular message for me, for Europe, is to have these collaborations not only with like-minded countries. There are many countries which are partly like-minded. And how do we deal with that? That actually is the real issue. Of course, there are points where you might actively seek collaboration to export our values. I mean, one thing which I find remarkable, in the 1960s, again, during the Cold War, there were many efforts to actively promote collaboration, to destabilize other countries by bringing the values of openness and transparency and inclusivity. And I feel this argument is less and less often made. And of course, there are points where you have critical knowledge, you might want to gain knowledge from the outside, you might be very protective of your own knowledge. Because I think an important thing is that these interactions are absolutely crucial for the well-being of the research enterprise, whether it's in the national one, whether it's the regional one, or whether it's the global one. And I want to share an image that actually I learned from somebody who was actually head of a Department of Defense in a very large country, the research head. And she said, well, knowledge is like a bucket that's leaking. And it's important, of course, that you try to fill the holes. But it's also important how fast do you fill up the bucket. How are you still able to attract knowledge and talent from around the world? And that's a quite delicate balance to strike. And so it's not only about losing knowledge, it's also about gaining knowledge. And I think to frame this debate in the right way, academies have an important role to play. So what can scientists do in this complicated world? Well, there are many things we can do. I think, the most important thing is to, what I like to say, push back against the pushback. It's actually a term I learned from the community that's about human rights, social rights, and they feel, well, sometimes, the forces that are pushing you are very well organized, very well funded. And, as an academic community, we have to organize ourselves in a way to make sure that we take common action, that we, so to say, hold hands and collaboratively work against those issues. And I think this is an active role to do. I think there are many ways, things that scientists can do that official governments cannot and diplomacy cannot. I think incredibly important that we avoid a risk-adverse, proactive behavior. I think this is a really difficult issue. I see in many institutions, if you be very concrete, you want to recruit a student, a postdoc, Is that from a country which comes with many regulations? Do you want to go through the trouble? Probably you want to. Those countries could be tremendous sources of knowledge and talent, but you want to actively promote responsible research collaborations and exchange. And there's, I think, a beautiful German word, vorauseilende Gehorsamkeit, anticipatory obedience. I think that's something that as a scientific community we have to be very careful for and not to do and push back against this. And also I think we have to advocate. International collaboration is not obvious. It's something that has to be argued for in the political domain, in the public domain, and see, as I said, there are many good arguments why we want this, the global challenges, basic research, and many others. And I think it's very important on all those topics we engage the scientific community. As I said, to navigate those two ills of paranoia and naivete, it means the active engagement of scientists. I think actually if you really want to make critical decisions, which areas, say in quantum technology or biotech or AI, you can collaborate or not, I think in the end it's the scientists involved in the research that have to make those decisions. So it's fine surgery. It's not an axis that should be used. And that actually means an important role for the scientific community. And again, I think academies can play an important role to send that message to the scientific community that you cannot shove those issues on the plate of politicians and governments because they're not able to do so. They just lack the detailed knowledge that the scientific community has. But it means in some sense that many scientists will be in the same position as nuclear scientists will be in the 1950s. And we have to deal with that. And I think an important role is to exchange best practices. That's why fora as this ALLEA are incredibly important. Exchange best practices. It's my experience that, in your own research field, it's quite common to have international conferences. As a physicist, obviously there's only global physics. But discussion of those policy issues, my own experience, many countries suffer from what I call the N=1 syndrome. There's only one Poland, there's only one the Netherlands. You have an absolutely unique system. These things are particular to us and to nobody else, and they're not. I think we share many of the same issues, and I think actually having venues like this, where we can actually share those best practices, our frustrations, our insights, our problems, are incredibly valuable. And finally, I think we should learn from historical examples. In my experience, these actually are a great way to motivate ourselves. So let me bring a few of those to you. So the first is the International Geophysical Year. The ISC, or in that time ICSU, had a long history of organizing polar years. There was one in the late 19th century, there was one in the 1930s. So in the 1950s, a few geoscientists said, well, shouldn't we organize a new polar year? But since this is the space age, this is a time where we can shoot things, we could be satellites, they hadn't existed yet, but there's an opportunity to study the whole planet. So there was this ambitious plan, framed in 1950, to collaboratively study the planet as a single system. In the end, I think it was 67 countries that participated, including the Cold War adversaries, the United States and the Soviet Union, and it was incredibly successful. It led to many issues. It led to, for instance, permanent Antarctic infrastructures, the big labs that you still find there. Interesting thing too, it saw the launch of 2 satellites. Of course, Sputnik was a big surprise for everyone. But soon after, where the US had their satellite, the Explorer, that actually, and they, particularly Explorer, did very important scientific discoveries. I will come back to it in a moment. And also, this is kind of open data avant la lettre. In the 1950s, they decided it was such a tremendous stream of data that has to be organized. So there was this group of data centers around the world was created to store all the insights of these investigations. And really interesting too, they decided to mirror the US and Soviet database because it was not quite clear that they would still be in communication in the long term. What were some of the scientific discoveries? So for instance, the satellites discovered what's called now the Van Allen belt. Van Allen was one of the proposals of this an American geoscientist. So these huge magnetic donuts around our planet that trap elementary particles, and they somehow protect us against solar wind and cosmic rays. So tremendous discovery. Ocean discovery, they discovered the mid-ocean ridges. So it's the largest volcanic system, 65,000 kilometers. And then was important support for continental drift, which only came into being in the 1960s. Things that you wouldn't have discovered just from your national perspective. And also interesting, this scientific event is seen as leading to what in many eyes is the most successful diplomatic event, which was the Antarctic Treaty. So in 1959, many countries came together and decided that Antarctica is a scientific preserve. They banned military activities. They created scientific institutions. And many of the insights we have now in climate change come from those infrastructures. So that sets the bar, I think, really high. And one of my fundamental questions is, do we as a scientific community have the audacity and imagination to do things in difficult circumstances? Well, another good example, by the way, would be CERN, the particle physics laboratory. Again, if you look at the history of CERN, you see many countries joined CERN before they joined the European Union. So it was also seen as a way to promote peace. By the way, interesting that just after World War II, all the European countries want to collaborate with the United States. And the United States, no, we are not going to do that. They also didn't want to share their nuclear secrets, but you work together. And of course, it's extremely successful. It's now the world center of particle physics. A modern incarnation, perhaps some of you know this, is this synchrotron facility in Jordan, Sesame. Incredibly ambitious effort to bring somehow peace through science in the most complicated region of the world. Of course, it's under a lot of pressure, but if you just look at the countries collaborating there, it's quite exceptional that you have those countries have such difficult political relations working together on a single central facility. It's somehow a spin-off of CERN. Another example that I found quite telling is this example. This is Mount Pictou. It's in North Korea. It's on the border of North Korea and China. It's some of the largest volcanoes. It's a sacred mountain for Koreans. And there's an active scientific collaboration with the US, UK, South Korea. I think France is also involved, working together on this volcano that led to one of the largest explosions ever recorded. Part actually of this scientific progress was about dating this explosion to the year 946, basically covered half the planet under ash, etc. So there is a common interest to understand these scientific phenomena. And it's also interesting that despite UN treaties, a collaboration like this is possible and in fact is allowed. Another example, I didn't prepare a slide, but the IEC has been quite instrumental in bringing together the scientific communities in another part of the world that we often not talk about, which is the Pacific Ocean. It's a huge part of the world, very tiny countries, countries like Tuvalu, 11,000 inhabitants. Sea level rise is threatening them in a very existential way. Very small number of active scientists. And what we created is a Pacific Academy, so at least those can form a community. It's a relatively small group of scientists, but again, responsible for roughly half the Earth habitat, and an important part, I think, of our scientific mission. So finally, what can Europe do? Now, there's no shortage of clear analysis of what's wrong with Europe. And my one-line summary is that the whole is often less than the sum of the parts, which I think is true. There are wonderful European institutions, but of course one thing that we're still confronted with, it's 27 nations with their own research and innovation policies, their own regulatory frameworks. They're working not in a coherent way. There's some explicitly work against each other. So that is the European project, to further align those practices and procedures and methods. And we'll undoubtedly, we will celebrating Maria Lepton and the ERC. But unfortunately, the European Commission spends 10% of the total European research budget. 90% is spent by member states, by the national system, and there's a lot of opportunity to align those. But actually, I want to talk not about the not good, but about the good here. So what are the opportunities of science in Europe? And I would like to say some of the things that often are mentioned as bugs, as issues, as problems in Europe, can actually be features. They can actually be played to our strength. So first of all, I think just to see what is the European ecosystem, is this quite special combination of collaboration and competition. A pluralism of ideas, a pluralism of institutions, of science systems, a culture of openness. If you see why Europe has played an important role in the past, it's often because it's openness to other cultures, where it's the Islamic culture, the ancient world, and a connectedness to the world too. One thing that Europe does, it provides stability. We like to complain about its complexity and inertia, but for science, actually, that can be a balancing act. I like to joke it's the square root n phenomena. If you see the fluctuations of n national policies, the average goes only with the square root of n. So if you're with 100, your fluctuation is only 1/10. The framework program that's right now negotiated is a 7-year frame. Actually, that's very long compared to national policies. When I started as minister, I was told that the average lifespan of a European minister is less than 22 months. I think it's going down even. And so you see, we are in some sense in a scientific world thinking of much longer time spans. Europe is open to collaboration. I think that's an incredibly powerful part. First of all, Europe itself has grown, the European Union, but there are now 20 countries associated. And there are many other countries which are more or less like-minded, where we have strong bilateral collaboration. So the fact that this is not a given unit, but something that can grow in the world, is, I think, an incredible strength. And this model of concentric circles, of more or less engagement, I think is also a model that can work in a bigger context. Infrastructure, already mentioned CERN. We host world-class facilities in Europe. And I think, again, the future shows that these large facilities are beyond the capacity, whether it's financial, of operational, of individual states. They're less subject to fluctuations. I said CERN is at this moment the center of particle physics. As you know, early 1990s, the US had a wonderful proposal of a supercollider. Was to be built in Texas. There was a change of US president, and certainly Texas wasn't that attractive anymore. And one of my favorite clippings, there was 3 kilometers of tunnels were dug. And one of my famous clippings, newspaper clippings, it says in the title, "World's largest wine cooler." Again, political fluctuations might intervene. And I think actually, and I think this is something that we can debate more, and it was really central also in the discussion this morning. There are fundamental values that Europe has, that it wants to promote, that it's tried to strengthen: the academic freedom, the collaboration, the openness, I would say the epistemic diversity, the various ways to look at research, the diversity and the transparency, and being, in some sense, citizen-centric, and I hope also being centric around early career scientists. That actually can be a real advantage in the future. I think the science needs a safe and welcoming home, and Europe can play a much more important role in the current framework, I would say. And indeed, this is the map of the countries associated to Horizon. You see that it ranges literally from Canada to New Zealand. And also, I think there's this phrase now that we're moving to, I like the phrase, a rectangular world. There are kind of power blocks of, obviously there's the US, there's China, there's Europe with its affiliated countries, and there's the global South. And if you think of those four major groups and their various relations among them, I think Europe has some important strength relating to all the other three blocks in their own specific way. And so being a connecting pin in this world where it's become more fractured, these relations become more tense, I think that is a very important role to play. And finally, I like to quote this gentleman, Steven Weinberg, who said, in my rephrasing, that typically in science we learn about nature, but sometimes in science we learn about science. And I think this is one of these moments. Not that we are, totally inward looking, but I think the scientific enterprise, as it was built, roughly in the last 80 years, it started after World War II with the famous report, the US report from Vannevar Bush, basically saying science was so instrumental in World War II that it could have a similar role in peacetime. So the advice was have massive investments, public investments in science, create research universities, research funding organizations, create this whole infrastructure, and it will be a public good. It will serve communities, serve society. And we just see that blueprint is being questioned, and at least, it needs an update, I think. And we are, in my view, right in the middle of this. And I think we're learning something about what science is, how it's positioned in the world, and it is in transition. You could say that we are searching for a new social compact where society says, well, we see the value of science, we are willing to pay our tax monies and what are the ingredients? I think we all probably agree what some of the important ingredients are. It's a public engagement, science communication, I think very important part, but also diplomacy. It plays an important role in shaping international connections, research security, dealing with it, transdisciplinary research. That's research not simply the academic practitioners, but there are many other stakeholders that need to be involved. And I think it's clear, at least for me, that we're in transition, but nobody has a perfect image to what exactly. But it's exciting that science itself is changing. International collaboration is key. I like to say that, politicians and intergovernmental organizations are sitting in the first ring of the geopolitical theater, call it the splash zone. Some leave the theater even. And we scientists are sitting in the second ring. And means we can do less and we can do more. I think we can do less because we are not in charge of government policies, but we can advise. We can think in longer time frames. We have a neutral convening power. We can work across borders where perhaps it's politically or economically more complicated, and we have this long-term view. That was incredibly successful in the past. And I think it's very important that we believe in those strengths, even though the future is uncertain. As I said, the global imperatives are more urgent than ever. All the big challenges, and by the way, the biggest challenge is perhaps that even those sustainable development goals, they have a target. It's 2030, and before we are in 2030, and there's now a big debate about what should be the future be. How do we set it? How can science inform an agenda that really delivers to the world? And how can we avoid that political forces undermine that? And I think, we have to strengthen those fundamental values. I often get questions, can we still do open science? Aren't you scientists be incredibly naive? Are you really living in the real world, a world of power and security, etc.? And my answer would be no, we truly believe in those. And by the way, these are not ideological goals, they are operational goals. I think the discussion we had this morning, what are the values in which we assess research? It's actually because we want to produce the best research with the best results that actually is benefiting society as a whole. So it's very important, I think, that we strengthen those values and make sure that they are future-proof. And finally, I think my overarching goal is geopolitics is too important to leave to politicians. Thank you very much.
Thank you very much, Professor Dijkgraaf, for both giving us hope and also energizing us and to think about what we can do as scientists. I see some microphones coming around, so we can have a few questions. Who would like to start? I can see. Yes, up on the back row here. And perhaps introduce yourself, yes?
Hi, I'm Alessandro Sfondrini from the University of Birmingham and the Cost-Action Fundamental Challenges in Theoretical Physics. First of all, thank you for the beautiful talk, Robbert. You mentioned that Europe has an attractive quality. It's a place of scientific freedom, academic freedom, democracy, and can guarantee these to many researchers. And yet, it seems to me that we struggle sometimes to attract talent from other countries, for instance, the US, or even to retain our own scientists with respect to other countries that invest more and create more opportunities. So what do you think Europe can do better in this regard? Thank you.
Yeah, I think, thank you for that question. And, in some sense, a brief answer is, of course, put your money where your mouth is, just to say, we're right now negotiating the next framework program. There are Lisbon goals that many countries set that are not actually reaching. So I think certainly important that there are enough means. But I think, and actually, it's also about thinking about what it means to be attractive. There are many ways, I think, in which the academic world itself can be more accommodating. Creating less bureaucratic hurdles, make it easier for scholars to travel. Part of the attractiveness of other parts in the world is the freedom that you get and the resources you have. So I think that's our important elements. I think actually, an important issue is also what is the analysis of many of those reports, is that we are more becoming a research and innovation union. We still have 27 different national policies. We are still competing among each other instead of competing with the rest of the world. So aligning those national policies, I think it could be real benefit. And I think we're all great fan of what the European Commission does, what the ERC does. But again, it's only a small part of the total picture. And I think actually to be really competitive, it should be much more a single community. And there are still many internal barriers, I think. And clearly the Commission is working this with the ALLEA Act and others, but we are not in a position to say that the academic environment in each of the many European institutions is as attractive as others. And I think somehow combining the strength is an important part. If you look at the statistics, now Europe is doing really well in terms of number of top research, etc. But the way they are connected, the way they form one community, I think, is not as well developed. And of course, that's the weakness. The weakness is that we have this complicated collaborative model. And what you see, I think, in many countries is that there's always this mix of collaboration versus competition. But you see in some sense that the dial towards collaboration is increasing. I always find it fascinating, this European Council of Ministers, it's called the Comparative Council. why it's called the Comparative Council, to regulate the competition among European member states. Right? It's not competitive with the rest of the world. And I think we need more of a collaborative council, I think. We have to kind of have a different shift in terms of how we organize science. And I would love to see that the central Brussels European mechanisms and instruments are kind of a magnet that align those national policies and also make sure that they, well, not only aligned, but that they're also roughly of the same magnitude.
So we can take 3 more questions. So we will start by the wall, and then we will take one yes here.
Hi, I'm Afia from the Royal Society of Scotland. My question, sort of linked, is how would advocacy and, I guess, pushing forward more collaboration and more academic freedom look like for both, I guess, more senior researchers, but also for the upcoming emerging scholars?
We'll take a few questions?
Yeah, it's a good idea. Let's take a few questions, then we can bundle it together. So next question is here in the second row. Yes.
My name is Ali Alpar. I am from the Science Academy, Turkey. Thank you for this very succinct and impactful talk. Fundamental contribution of science is its philosophical value, especially in the current dominant climate of kind of political and moral hypocrisy based on fake and alternative truths. My suggestion is whether something can be done really highlighting the epistemological value of science, that true, reliable knowledge is possible only and to the extent of interaction with the actual world. So the question is, what would you say about an international year of science or international year of knowledge? Yeah, that's the question.
And then we have another question behind you, and then we have one here.
Neri Salvadori, Accademia Lincei and Board of ALLEA. I was impressed by the number of common activity, scientific activity, which was done during the Cold War, that you have expressed very well. And now, but at that time, the only military science was covered. Now, on the contrary, we are in a situation where there is a lot of research which is done within big companies. I think, I don't know the statistics, but I think that the amount of money spent by big companies in research and kept covered, unknown to other scholars, is even bigger, or at least comparable with the enormous amount of money which is spent by the public, including military. And I think this makes a problem and maybe questions.
And then we have here. Here. Isn't it here?
Thank you. I had a related question. Noel de Miranda, the Young Academy of the Netherlands. I mean, you mentioned about pushing back and the need of governments and scientists as a community to set up a system where we can collaborate and work together, walking towards a context of academic freedom. At the same time, you mentioned how technology is about to revolutionize the way we go from building blocks to actually do the building. And a lot of these technology is being developed in the corporate world, and you see centers of power shifting. How much power will governments still have to actually be able to set up an ecosystem that allows for scientists to operate. Thank you.
Okay, we will close for the questions now, and then let Professor Dijkgraaf try to answer this question.
So let's start with, thank you for these beautiful questions, and they all, warrant a much longer discussion. But let's start with the, early career scientists, I think, it's incredibly important that, and we had the discussions this morning again, that science is a welcoming community. And, one phrase I learned is that we often talk to be inclusive. And I once was giving a speech, and then somebody said, can you please stop using the word inclusive? Because it's about how you fit into the system. And you should use the word expanding, because it's not about how you fit in the system, but how the system can grow so that it actually covers many more voices and roles. And I think this is a very important lesson. So I think one part of that, I like to say, not fitting into the system should still fit into the system. So we talk about, having radical ideas about whatever kind of government policies there are. There should always be room for somebody who doesn't fit into it, etc. So growing as an institution, I think, is incredibly exciting. And I think but often we put the burden on young people, from other strata, where it's first generation or from parts of the world, where just the path to go to, in the end, join the scientific community is just too long. So I think we have to be proactive, I feel, here. And again, these are things that the academic community can set by itself. It's not dependent on government policies. I think that's something that universities, research institutes, etc., can do themselves. So that's an important message. And as I said, it's not about an ideological goal. It's just to be maximum in what we want to achieve. And I think I've learned it's an important thing. There's a universal right to be a universal human right, to be right to science. Not all of you are aware of this. And there's no distinction between human rights. They're equally important. That means that everybody has the right, a fundamental right, and most countries signed off on that right, to participate and to benefit from the products of science. So that's an important thing. We shouldn't debate whether it's a good or a bad thing. It's just the world agreed that there is such a thing. But then we have to grow towards this. Then the question about, I would say almost the overarching values of science. As I said, you're speaking on this important stakeholder, which is empirical reality. But you asked even deeper, just understanding the world around us, understanding human behavior, human knowledge. And we all feel this is a tremendous public good, that everybody should be benefiting from. And I think there's a certain risk that we position ourselves too narrow. That we say, well, we have an important role to play in technological development. And it's true, but there is a bigger story to be told. Speaking on more or less on behalf of the truth, whatever that be, or the best approximation to it. And again, as I said, it's very important that the humanities and the social science are part of our effort. And by the way, it's interesting, when the ISC started in its first incarnation in the late 19th century, from the very beginning, the humanities and the social sciences were part of it. In fact, from the UK is interesting because there was only a Royal Society, so they had to create a British Academy to join the ISC. So that has been a part, and the unity of knowledge, I think, incredibly important. There are international decades or international years. I think, I agree we need this, but we in some sense should put it in practice in a way. And then there were two questions about the role of companies, and I think it's totally right on the mark. So first of all, I think, our general, even in Europe, we feel that the right balance would be roughly public versus private research and development as basically 1 to 2. But of course, it's a lot of development that happens in industry. So, a lot of things are just improving products, etc. I think you're pointing out that we see a rather dramatic shift into private hands. In the United States, the multiplier is now 1 to 4. So for every US dollar that the federal government spends, US companies spent $4. This year, the US tech companies will invest $700 billion just in 1 year in building these infrastructure, sort of large data centers, etc. Now, if you think about the big public scientific projects, I mentioned the development of nuclear arms, the scale of the Los Alamos project, etc., Manhattan project. I think we still have projects on that scale, but these are the huge data centers that are actually totally private, and nobody knows exactly what's happening. And we all love to use AI, but we, of course, dependent on those companies. And I think that's quite frightening, I must say. And in my presentation, the private companies were totally absent. So that's right, because perhaps I don't know exactly what to do there. And I think they're a little bit in our blind spot. And perhaps because we looked a little bit, down on companies and felt, well, it's not really interesting what's happening there. It's a lot of development. We have breathtaking breakthrough discoveries in the life science, and then they go to the pharmaceutical companies and they make products out of it. And I think these days we could have important scientific discoveries coming out of this. The Nobel Prize to Demis Hassabis and John Jumper for DeepMind's AlphaFold is an example. Although I joke, it's basically the AI that got the Nobel Prize, but because only the AI knows how to fold proteins. But this is something that we might see more in the future. And actually, it's an existential question. What does it mean for our community? And what do we do with our colleagues that are working in those laboratories? And are not those the kind of walls that we have to break through? And I think it's a real existential question, and I don't really know how to deal with it. But obviously, this will be determining the future of science to a large extent. Again, you often ask academies, do you have members that are working in those research laboratories? That might be one way to interact with them. Often not, or very few. So this is, again, I think, a territory that we have to explore. But I think both of you are pointing out this is, again, a remarkable point of inflection in the development of science. And how the fact that these 5 tech companies spend roughly 4 times more than the complete European public research budget in a year tells us something about the forces that are operating on our community. Okay, thank you.
Thank you so much, Professor Dijkgraaf. And now there is a short intermezzo. You have the possibility to have a little coffee outside, but only if you speak to somebody that you haven't said hello to yet and you don't know. And in 10 minutes, the panel will start here, so please come back as soon as possible.
Oh, I forgot.
can I find it? It's YouTube ALLEA. Yes, yeah, YouTube ALLEA. Perfect. Just typing the ALLEA into YouTube. Super, perfect. Thank you.
Yeah, that's coffee. It's a mistake. Ladies and gentlemen, please come back to your seats. May I have your attention, please? Hello, hello. Okay, thank you very much. I think the break was longer than planned, but probably we should take it into account. It was just too short. We are after inspiring lecture of Professor Dijkgraaf, and thank you so much. It gives us a very good background for further discussion. And as a geophysicist, I love this example with the International Geophysical Year. We are now in the time of preparing of International Polar Year. I am just wondering whether we can use this opportunity as our predecessors did in the past. So now, after this general introduction, and after we realize that the challenges we face in Europe are not isolated, and these are just part of a wider transformation affecting how science relates to politics, society, and global cooperation, we now will start a panel that is intended to take us beyond these reaffirmed shared principles, such as academic freedom, institutional autonomy, openness, and integrity. We will go towards examining what it actually takes to defend and sustain them in practice. We have a very rich panel with excellent panelists, and to guide us through the discussion, I am pleased to introduce Andrzej Rychard, who will be the moderator of the panel. Professor Andrzej Rychard is a sociologist and a long-standing director of the Institute of Philosophy and Sociology at the Polish Academy of Sciences. And his research focuses on post-communist transformation, democratic governance, public institutions, and relationships between the state, the market, and civil society. He has also been closely involved with the Stefan Batory Foundation, where he has served as chair of the board, contributing to public debate on democracy, civil society, and the role of independent research in Poland. And I believe Andrzej is probably among most present scientists in Polish media as well. So that's... Professor Rychard will also introduce our distinguished panelists. So Andrzej, floor is yours. Thank you very much.
Thank you very much, Paweł. It's a great honor to be here, and I'm really grateful for the invitation and for the possibility to moderate this panel. First, let me introduce the panelists, and then I will tell you about the format of our panel, since we had already a preparatory panel headed by Daniel Kaiser a couple of weeks ago, and we have prepared how we want to organize this. So first is Barbara Prainsack, who is coming from European Group on Ethics and in Science and New Technologies. Then we have Emilia Stojmenova from University of Ljubljana, Caroline Sutton from International Association of Scientific, Technical and Medical Publishers, and Krzysztof Pyrcz from Foundation for Polish Science. I have been already introduced by Paweł Rowiński, and my role is the following. We have already addressed three main questions for each panelist, and I will be asking all of them, each of them, to address these three questions that are basically the same, with the exception of Caroline, who has very specific ones. And therefore, I would like first to address these questions, Barbara, and let me say what these questions are. The first one is, what makes a research system truly resilient today? The second one, how can Europe stay open without becoming vulnerable? And the third one is trust in scientific institutions, and are the conditions changing? Altogether, we have 75 minutes. We have started a bit late, but we have been allowed to continue, let's say, up to maximum 10 minutes past 4. So that's how I see it. So Barbara, please address these three questions. First, approximately 10 minutes, okay, like that.
Thank you very much for bringing us together. I'm very honored to be here. Good afternoon, dear colleagues. I'm not sure whether I will address this question in sequence, but let me start with the topic of the first, resilience. I should also maybe reiterate that I am here on this panel as the chair of the European Group on Ethics in Science and Technology, which is a body, an independent advisory body to the European Commission President. And I'm also on the ALLEA Standing Committee Science Policy. So resilience, I think resilience is one of those words that we all hear about a lot, and we hear it mentioned, and very often it's not defined. We don't really say what we mean when we use the term resilience. I think there's a certain tension there also, especially among politicians, not so much policymakers. I think that's also something that I would like to distinguish. I'd like to distinguish between politics and policy. I think the dynamics are very different. Politicians often talk about resilience and mention it in the same breath as they mention cost cutting, for example. And I think we can't have it both ways. We can't serve the goal of a strictly or narrowly understood notion of economic efficiency on the one hand and be resilient on the other. A system that is resilient, as not only material scientists know, a complex system such as science that is resilient has features such as buffers, redundancies. And I think in a situation where also science and research in many places of the world has been optimized to be efficient, this has already come at the cost of resilience to some extent. So if we want to create really resilient institutions, we have to have those redundancies. We can't build systems that just work in a kind of, that are built for normal functioning. As soon as the first crisis comes, those systems will become very, very brittle, and they might even break. I think another example was COVID and healthcare systems. So when healthcare systems are already working on, in many contexts, in many countries in the context of austerity, when they're already working with a minimum that's necessary to be efficient, then they will not be able to withstand crises. So if we want to have resilient science and research, I think we need to think carefully about what we invest, what the future needs, and what are good savings, and when do we confuse cheap with cost effective. And I'm grateful to our keynote speaker who already brought in the notion of zero-sum thinking. I would disagree that politics is always a zero-sum game. I think not always, but zero-sum thinking is a big problem here, because zero-sum thinking, and there's a lot of research in economics now on zero-sum thinking as well. Zero-sum thinking makes us assume that if you give something to one group or one purpose, you have to take it from another one. And that's sometimes the case. When you have an annual budget, that's the case. But it's very often not the case, and especially not when we invest in science and research. So researchers benefit, younger generations of scientists benefit, and economies benefit. So everyone benefits from smart and good investments and from certain numbers of redundancies. And redundancies is actually often seen as a bad word, right? But I mean it in the sense that it also includes the acknowledgement that we don't always know what we need. So there's now also this notion of low-value subjects, to refer to some scientific disciplines that don't produce a lot of economic value or are not seen as producing a lot of economic value. And I think that's also a very, very dangerous path to go down. We don't know what kind of disciplines and what disciplinary knowledge we need. Think of virology or think of epidemiology, which was a sort of niche subject until HIV/AIDS started and COVID needed this kind of knowledge. Think of cryptography, which was a very, very obscure field almost, and then during World War II, it changed the course of events. So resiliency also means that we need a kind of plurality and no a priori or no hierarchy of disciplines, certainly not according to economic, in the narrow sense of the word, narrowly understood economic parameters, because we never know who is going and what type of knowledge is going to save us. So if we talk the talk of resilient societies, we need to walk the walk of not accepting the idea that science needs to be as efficient as possible, as economically efficient in a narrow sense of the word. And my last point is that it has also implications for academic freedom and democracy at the end of the day. Academic freedom and democracy, of which academic freedom is an important part, is not always threatened by outright attacks on scientific institutions and academic institutions. Also, fiscal decisions can erode institutional capacities. In many places it starts like that. I'm speaking as somebody who's based in Austria, where as we speak there are demonstrations against severe budget cuts that universities are faced with. And this is by no means an Austrian particularity. Again, this is not, my plea for resilience is not an argument against the prudent use of public funding, but it is a warning of the idea that economic efficiency and resilience can be had at the same time. So it's about smart investments and not about getting things as cheap as possible. I haven't spoken about openness, but we might get back to that later on.
Thank you very much. Before I address these questions to Emilia, there is one thing which I forgot to inform you about. We envisage also to have a short, let's say 10 to 15 minutes Q&A session after all panelists will express their views. And now, Emilia, the same questions. What makes the research system truly resilient? How scientific system, how can Europe stay open without becoming vulnerable? And trust in scientific institutions. Please.
Thank you so much to ALLEA and to the Polish Academy for inviting me. And before I start with answering the questions, I would like to express my full support and solidarity with the Polish researchers. I hope that the Polish government will hear your demands.
Sorry for interrupting you. You may not know, but this day, actually at 1:00 p.m., a huge protest gathered in front of the Polish parliament. And for the first time in our history, as far as I know, the protesters are not miners, not shipyard builders, whose protests are usually taken care by the government because they are very loud. These are researchers, scientists coming from all over Poland, and I do not know how big it is, but definitely if I wasn't here, I would have been there. So I understand that these are very important words. Their request is only one. We want to have at least 3% fund for spending for the Polish, as the proportion of the Polish GDP. Now we have 1 point something percent as far as I know. Yeah, definitely. Sorry for interrupting you. Please,
no
please
problem
continue.
at all. I started. Thanks a lot for the questions. My field of expertise is digital transformation. I also had a career in politics and policy making, because sometimes politicians can do policy making as well in digital transformation. That's why this is the angle I would like to speak about. Yesterday we listened to the Ukrainian researchers, and we were speaking about resilience. I would like to remind us all of what happened in February 2022. When Russia invaded Ukraine in February 2022, the University of Kharkiv, which is one of the oldest universities in Eastern Europe, a lot of infrastructure was destroyed there. I'm speaking about physical infrastructure. Luckily, the researchers migrated their data earlier, mostly to European providers, also to some commercial US. But what was the result? Because of the attack, the work was not lost. So they were able to continue because they migrated the data earlier. So the building, the physical building, did not really matter. And now I would like to ask a question for you all. Do you know where your research data is stored? How many of you here know where your research data is stored? Where is the cloud?
It is physically somewhere, definitely. Not it's floating in the air.
Yes. But this is very important. It is very important where this cloud is and under which jurisdiction. So what happens if that jurisdiction changes? What happens if export controls are changed? What happens if terms of services are changed? What happens if the political relationship with that country somehow is changed? Because these are things that happen in reality every day now. And most of the directors don't have the answers to these questions. They don't know what is happening. Another big issue is the Cloud Act. I'm not sure if you're aware of that, but the US, they have Cloud Act. Because of the Cloud Act, the US authorities have access to all the research data, all the data that is stored by their companies, regardless of where this cloud is. So even if these servers are physically here in Europe, but they're owned by US companies, means that the US authorities can have access to this data, and research data is included. And this is a big, big issue. Professor Dijkgraaf earlier said that in Europe we have world-class facilities, and I completely agree with you. Let's just think about the CERN. I'm very proud of that. I'm proud as a European. But when it comes to digital infrastructure, in Europe, we don't have digital infrastructure that is owned by us. Most of the digital infrastructure that we are using is used by few American companies, corporates. So the second question was about openness, how to stay open and not become vulnerable. Yesterday, we had a representative from the European Commission, and he was sitting behind me, but I cannot see him now. I wanted to praise them regarding the policy of Horizon Europe, that if we get public funding, we need also to publish our data openly, our research openly. This is a great policy. I like this policy a lot. But what is the biggest problem? So on which platforms open access, that offer open access, where these platforms are? So which are these platforms? ResearchGate, Academia, PKU, and so on and so on. Again, we are speaking about platforms that are mostly in the US. They are not here in Europe. And the big problem is they're governed by European rules. Another thing is that they're using our research data to harvest their AI algorithms. And what is the big issue after that? They're selling us their algorithms, meaning the European taxpayers. First, we fund our research. Then we mandate for open research, which is great. But then all our research is used by by providing food for these AI algorithms that are then sold to us. So what can be done here? Should we close all our data? Should we close all our research? No, definitely not. But what is necessary here is to require that publicly funded research infrastructure, repositories, data commons are collectively governed under European jurisdiction. And we do have many mechanisms and instruments already there, but the problem is they're there and they're not used. So they should not stay only to recommendation, but if you want to get public funding, then also you need to use European infrastructure where that can be audited as well. So to make compliance a condition of participation instead of a recommendation. And again, I'm not about closing, about not collaborating with the rest of the world, just with us, with Europeans. And since we're here at Copernicus, it can be given a very good geographical metaphor, because he also worked in a broader space. He didn't work in one region, one country only, but institutionally he was grounded in structure he could first navigate and then trust. So it should be the same also when it comes to research. We should collaborate with institutions, with governments. We should have partnerships where we can trust, and we can have a say in the navigation of them. And then the last question was whether the conditions for trust in science are changing. Of course they're changing, not only changing, but they're dismantled from multiple directions. And why is the reason here? First is speed. So we want everything to happen very fast. We cannot wait. And in science, in knowledge, things don't happen fast. If you want to come with some conclusions, it takes time. So what happens now, even when a preprint is published, media takes this preprint, they start explaining what is happening, but this preprint is not even reviewed. So it's not necessarily true what is written then there. And what the society can see out of that, they can see a chaos. And that's why they are losing the trust. But knowledge happens because of this chaos. Then another thing is the social media. There is no single algorithm social media are using that will put on the first place when somebody is saying, based on data evidence, and then if someone says, they're hiding this from us, trust me, the algorithm will choose, they're hiding this from us, they're lying. So all the time the social media is giving priority to outrage. Then another thing, artificial intelligence. So we have fake articles, we have synthetic data, we even have fake reviews, and media is speaking all about that. So people don't know whether there was a real science behind that, whether there was a real scientist, and this is why it influences a lot also on the trust in science. And the last, it was very well presented earlier as well, the geopolitical issue. So I would not get into that. But to somehow conclude that people nowadays are exhausted and overloaded with information. So if in the past we were getting the information from the schools, from the universities, medical information from your doctor, or I don't know, from the newspaper, it doesn't exist anymore. So you get information from many, many different sources, and people don't know who to trust more. What we can do as scientists, what we are usually doing, we are presenting the results, but we forget about the process, so how we got to these results. And I believe that when people see the whole process, so how we achieve those results, they will maybe be able also to understand and to trust science and scientists more. Yeah, that was all.
Thank you very much. Just to add one thing to these issues related to the cloud, I have just read a great book by Polish journalist Sylwia Czubkowska on how these big technological companies colonize the world. And actually, this cloud is very physically located somewhere, but this somewhere is very difficult to discover where it is. She was trying to find the places in which one of the American companies, because usually these are American ones, is planning to build a huge farm of servers. And nobody knew, nobody informed her where. At some point, some local authorities discovered that something is being built, but they didn't know anything. So this was also the strategy to eliminate the probability of protesting, because people do not know that there is something which they could protest. And they could protest because, you know, there is a huge, huge challenge for the local natural environment. It's a consumption of water, consumption of energy, and many, many other things. So that's something which is also taking place right now here, in this place, close to Warsaw actually, but nobody knows where exactly. Okay, thank you very much. And now I would like to address these questions, these 3 questions, to Krzysztof Peric. Please, the floor is yours.
Thank you so much. I would like to start with the notion that looking at these 3 questions, I started to think that we have a problem because we treat these questions as technical questions, and these are not technical questions. The problem is that these questions are only marking the problem, and we do not know actual technical questions. So we say that we need resilience, we say we need to be open, we say we need trust, but we are not saying how to secure, for instance, our cloud, because that's just a part of the problem. These 3 questions are actually adaptive problems. So they require not only finding technical problems that we can solve as scientists, I'm a scientist, but also to identify broader problems, except for technical problems, and also maybe we need to change the paradigm, and maybe we should have to change ourselves. So going to the first question, how to ensure the resilience of the research system, that's a very interesting question, because what is resilience? So how to stay, how to be effective when everything actually falls apart. We can think about technical questions here, or technical problems, how to secure funding, how to secure data, how to ensure that the information is flowing. But the problem is that we did see a country, a very big country recently, that had all the funds and all the physical capacities, and yet the system is degrading very rapidly. So if you would ask me this question like 15 years ago, I think I would give you a technical answer, but we happen to live in it's nicely called VUCA world, so world that is volatile, uncertain, complex, ambiguous. A world where actually black swans are not isolated events, but they come in herds, they change their habits. Every year in the beginning of January, I'm waking up and thinking, well, it cannot be worse. What? It can. So let's hope this will finish. But how to ensure the resilience of the research system in such a time? So I think that we should go back to where the resilience comes in the VUCA world. So I would say what we need is education, it's autonomy of scientific units, it's competence, and it's actually democracy. Why I'm saying that? I'm saying that because the resilience is provided by variability. I had a very interesting discussion some time ago about the fact that the most important discoveries are made during the times of crisis, like war, like pandemic. This is the time where actually the efforts precipitate. But the point is that between these points, the basic research, the fundamental research creates variability that may seem to most of us useless. But when the crisis comes, like with bacteria or viruses, I'm a virologist myself, so I also have a few remarks about trust in science. So when the crisis comes, it's selected. So out of this huge pool that is being generated by brightest minds of the globe, things that are needed survive and allow us to flourish. So I would say we need to support basic research. We need to support autonomy of scientific units. We need to support education of the society. And if you would ask me now the question about how to maintain the research system resilient, I think we should focus on these factors. We should not forget in the world that actually tries to push the science into the support for business, into that direction. We should not forget about business. We are also here for the economy, we are also here for the society, but we should also remember about the value of the fundamental research. And even though it may not translate right now into US dollars or euros, it creates this variability that actually made us the most powerful species in the world. I'm often saying that the thing that truly distinguishes humans from animals is the science, because that's the only thing that allowed us to get where we are. So VUCA word, black swans, and autonomy and basic science. Second question, how to stay open. On purpose, I said stay open, not to become open. The problem is that we are facing now, in my view, is not how to become more open, but to how to stay open. During the Second World War, the last paper from theoretical physics actually appeared on the 1st of September 1939. It was completely ceased after that time. We are very dangerous times when we may see science being closed down in single countries. We already do see that our access to some countries' science is very, very limited. If we go this direction, we may see great isolation that will stop actually this variability and diversity generation process, so basic research, that would be very, very bad. But then we often hit a problem when we are speaking with politicians who are asking, okay, but why should we produce global science? Why should we take the money and not give it to medical doctors, but give it to science that will not pay back to our citizens, because we are politicians, so we want their votes, simplifying. And then that's a very, very important question. I will go back to the first question about education. If we don't explain and maybe change the way we are thinking, and then explain this process, why basic research is important, there would be no notion of the value of the basic research in the decision makers, because we are all beneficiaries of the global science. That is correct. And the question is whether we want to be beneficiaries of the science that is being done in the US or in South Korea, or we want to have resilience also in Europe. If we want to generate this diversity, this variability also in Europe, to be prepared for the breakage of the value chain that happened during COVID partially, but may happen to much larger extent. If it were coming to the open science and the restrictions more pragmatically, I would say that what we need to stay open are clear guidelines. That's all, like my opinion, that scientists that I have spoken to very often are afraid of the consequences of what they are doing. Sometimes they completely don't pay attention, but I notice more and more that people start to think about it, whether I should collaborate with a person from this country, whether I should, whether I can, whether there will be consequences if I collaborate with a person from this country. So without guidelines saying, well, it's okay, guys, to collaborate unless you're working on something that can be weaponized. It's okay to collaborate because science is a language of diplomacy. Without these guidelines, we start to limit ourselves in this collaboration. And I do see that amongst my colleagues. I don't know if it's a global thing, but that's what I have noticed. Without guidelines, we are trying to restrict ourselves sometimes to a very large extent. And then the last question, trust in scientific institutions. Oh, that's an adaptive challenge. What is trust? I mean, with science, we got to the point where science is so advanced that if you're not a specialist in a certain branch of science, it's close to magic. That's why we're talking about trust in science, because we cannot explain to people who are not trained in a certain category so they can understand, so they have to trust. And then we say, well, okay, you have to trust us. And they say, well, if it's coming to trust, we don't trust you. Why should we trust you? And then there is another problem that we have to think. If we're talking about trust in science, we have to consider what the science is for. Whether science should rule the world. Do we want to live in a meritocracy, or we want to live in democracy? there is a huge difference. And then I personally would prefer democracy, because even though we, as a scientist, I think that the decisions should be merit-based, but we often, I'm talking about myself also, we often as scientists forget that the fact that something is true, what we should fight for, doesn't mean that everybody should obey. Because if we try to present it this way, then we are starting to be a competition to some some political leaders, and we start to impose things that they have to do something, and they don't like it, not at all. So if we're talking about trust in science, I do think we need to change the paradigm we think about why people should trust in science. We should go more into the product, into delivering things, into thinking about building the capacity rather than saying what's wrong and what's right. And I think most of us, as I said, I'm a virologist, so I fall into this trap myself. I was also saying this is right, this is wrong, and I'm not sure. I'm sure it's not correct. We should say, well, according to the knowledge we have, if you do that, you have higher probability that you will die. But it's your choice. Otherwise, we actually undermine the trust in science. But to be just a bit optimistic at the end, I would like to say that we are talking about lack of trust in science. Well, still, majority of our societies still do think that vaccines are good. Majority of our societies accepted RNA therapeutics, which were a huge thing. I mean, RNA therapeutics, that was very difficult to move from the laboratory phase to the clinical phase, because people were afraid of that. So people accepted that. Majority of people got vaccinated with this kind of vaccines. We accept the fact that as societies, we accept the fact that merit-based decisions are right, but we still have a long way to go. And with that, I would like to finish, and I think I'm over my time. Thank you.
Thank you very much, Krzysztof. And now let's move to Caroline's reaction. And this will be more on less on the level of general values, but more on the level of more operational realities, I would say, and mostly related to the problems with publishing. So Caroline has her specific 3 questions, and they are the following. What kinds of research communication infrastructure are needed to support resilient research systems? That's the first one. As AI accelerates the creation and dissemination of content, what will be required to sustain trust in this scholarly record? That's the second question. And the third one, in a fragmented geopolitical and technological environment, what does responsible stewardship of the scholarly record look like? Floor is yours, Caroline, please.
I'm on now? Yes, thank you. Thank you so much. First, I really want to say thank you so much for this opportunity to join all of you and to listen to the conversation and to take part in this conversation today. I've had many engagements with Pavel and discussing collective issues that we know we have, equally with Sir Peter Gluckman, who's the current president of International Science Council. I look forward to speaking and carrying on some of this with you. And I think this is, if anything, I would just say that what the keynote earlier really brought to light again for me is that there is just so much that we have taken for granted in the post-war period. As we've been developing our liberal, global democracies and economies and means of engaging around science. And so I think this is that moment where I'm seeing in the conversations I'm having with other leaders of other types of associations. So I'm representing the global scholarly publishers, all from the biggest all the way down to tiny societies with 2 or 3 journals, university presses, and everything in between. So I know a lot of people think, oh, this is Caroline coming to speak from a certain publisher, but it's not. It's all of that. But I think what I'm hearing when I meet my counterparts with other associations, be it universities, be it societies, et cetera, it's all this moment of really trying to think about what really matters right now. What is it that we need to preserve? What is it we need to protect? And I think that gets a bit to that question of resilience. So 2 things that I wanted to just begin with were things that I've been thinking a lot about and discussing in our association is, number 1, some of you may have read the work of the historian Yuval Harari, and he talks about self-correcting systems and the importance of these systems. And he talks about democracy as a self-correcting system, but also science and the communication of science as a self-correcting knowledge system, right? We have mechanisms built into the way in which we work, our methodologies, the way in which we communicate this, that means that as we start to branch in that genealogy of knowledge about a particular thing, when we discover that this might not have been correct, we correct over here and we start moving in a different direction. Equally, if we discover that someone has made a terrible error, either on purpose or inadvertently, we're able to go back and correct that, right? So we have a self-correcting knowledge system. And that is hugely important right now in this moment when, as you were pointing out, Amelia, survey after survey is showing that people no longer know what to trust, right? We had social media that through algorithms has twisted that perception of what we might be able to trust. And we've now layered on top of that, for all the good that AI can bring, it also is biased and delivering information that we know is not according to the ethos of science as we would think of it, right? It's not handing us answers that also show us the genealogy of knowledge of how it arrived at that. And so as we in the publishing community know that I can't be here to tell you, so here's how you should conduct science, but we are here in service of your science to help communicate that. And so I think what we're kind of gathering around in this moment is, how do we think about ensuring that in a world where we don't know what to trust, how do we ensure that we have a body of knowledge that we can trust? So what are those mechanisms? So to that first question around resilience, and I'm just putting out a few things because I think that we could think about in many ways, but I think thinking about that self-correcting element, because we take that for granted, right? But what does that really look like? How does it play out in practice? That gives us some hints about what do we need to be very, very protective about. We might change the mechanisms by which we correct and self-correct, but the core of that needs to remain there, right? So how do we protect it? How do we evolve knowledge? How do we avoid actions with unintended consequences that could erode that? Where are the gaps in how we are working to self-correct, and how do we close them? And I think related to that, in my mind as well in this moment, is really thinking about checks and balances. So how do we ensure that no single entity is able to define this is what should be scientific knowledge, right? We have had instances in some countries where certain governments have come in, and for example, from the publishing perspective, we've seen, for instance, in one country where the publishing was taken into the state and the history books were rewritten, right? So we need these redundancy systems, checks and balances, then say, okay, that might be that, but we've got another source of that information over here that we can then compare with and think about. So I think that's very important, and it plays into, I think, in publishing in more different ways, but I won't go into those details right now. And I think has already been repeated multiple times, and this is also important to us as publishers. I mean, journals are where you have editors from all over the world. We have editorial boards from all over the world, or at least should, and we have reviewers from across the globe, right? And the whole notion is that we should be able to communicate that knowledge, that protected knowledge, across borders. And so I think another in the resilience is about that this needs to be a global conversation. But we are in a fragmented world, and that creates pressures that could lead to siloing systems, to competing standards, and to restricting collaboration. And so I think that that's really important. And part of that continued collaboration, and it's been mentioned already as well, is thinking now as well about how do we think about researchers who find themselves in a conflict zone or are in the diaspora because they've needed to leave their home country. How do we ensure that that communication continues? So we too have been thinking on our end and working with groups around, for example, with Ukraine, also been supporting some efforts around the Ukrainian university publishers to think about how do you keep that going? How do you maintain a position in the global conversation about these things? So although we're going to get into details, I think I'm pulling it up a little bit, and that's a bit of a nice thing to be able to do that and not just to get into the details of publishing. But just to say too, AI, as I was mentioning, is one of these bits because we talked about the integrity here, trust and integrity. I think, again, if we need to protect that this is a body of knowledge you can trust, we'd better darn well make sure it's trustworthy. And that's where research integrity comes in. And unfortunately, it's also where of all the good that AI can also help us to do some of these checks and to support some of the workflows and various things, equally what we're seeing, and I'm sure you're aware of, if you work on any journals as an editor, we are receiving a deluge of submissions with research integrity issues because technology is assisting that. And so I think that this focus, and I really appreciate that ALLEA has put together this work around research integrity because this becomes so imperative for us all. We each have a role to play from our position as an institutional actor about how do we improve that situation. And it is not a problem that is just out there. I have also heard stories of an editor on a journal here in Europe who is also operating a paper mill. So, I mean, this is, we've got to be careful and we need to ensure that we're supporting good practices. There's much, much more that one could say, but I know that we're running short of time and I know we also want to have a conversation. But I did want to just share with you some of the thoughts that we're having from the publishing community about how we want to help continue to support that communication and to protect that self-correcting knowledge system that you're all contributing to and are a part of. Thank you.
Thank you very much for all our panelists. And now I would like to encourage the audience to take part in our discussion and please address your questions. Yes, please. That's the first question in the second row.
Yes, thank you. I'm Rudy. I'm the manager of SAPEA. I'm wondering, by the very positive keynote of Robbert, but also by your contribution, why we are talking not about resilience, more about laws which protect science, procedures, for example, multi-annual frameworks which protect research projects, maybe autonomy which protects maybe or maybe not, universities, research organizations from political influence. We are talking often, and I also include myself, about, yeah, well, we need this democracy to function, but we also don't define what is democracy. I mean, I know Orban is saying, yes, Hungary was all the time a democracy. You can see that because I'm not prime minister anymore, yes? But is this the definition of democracy, what we have? So there are gradually differences in democracy. So there are threats even in democracies, and we see this, I would say, in the majority of the countries in Europe. How to deal with that? So how can we make our research and science systems more resilient to this big trend of right-wing parties, but also to this more polarization, what we see, so that we have right-wing parties at the one time and then maybe left-wing on something on moderate or whatever, or we have the Polish situation, which is extremely difficult, and how to navigate our organizations and our research through this by changing rules, laws, frameworks, and all these kind of things. This would be my question to you.
Who would like to respond? You'd like? Please go ahead. This was mostly to you.
As a political scientist, I feel I have to respond to this. Thank you very much. So first, your concern that we use the term democracy very lightly and we don't define what we mean is absolutely well taken. I don't mean to prescribe any definition, but I think the definition of the VDEM, Varieties in Democracy, project in Göteborg is very useful. They analyze all regime types every year according to around 500 indicators, and they've got 4 types, ranging from liberal democracy, so this has nothing to do with liberalism as a kind of ideology, but it means it's a it's a democracy that has free, fair, and equal elections, but it has checks and balances. It has independent journalism, media, and also independent science. So in a way, this is the highest form of democracy. Then there are electoral democracies that have elections, and the elections might be free and fair, but they miss some of the other checks and balances. They miss some of the pluralistic debates and the factors that enable them. And then you have electoral autocracies and closed autocracies. And in science, I would say, and this is, sits a little squarely with what you said, science and research plays a key role in any democracy, especially in liberal democracy. And the tricky thing is that, as I said in my initial statement, or as I alluded to in my initial statement, that often the erosion of scientific freedom doesn't start with outright intimidation or the sacking of scientists. It starts with actions, sometimes even fiscal actions, that make institutions believe that they now need to self-correct, but not in the way that you mentioned, but in the way that get rid of disciplines that are not so useful, get rid of disciplines that are not so economically useful. That's the start, very often. Then academics start to self-censor themselves because they feel if they don't research the right subjects or if they say the wrong things, they are the first ones on the firing line. So challenges to liberal democracy are sometimes a little bit more silent than we assume. And how can we protect ourselves from that? First of all, I think by being political, not in a partisan way, but political in the sense that as people dealing with science and research, we articulate a firm commitment to democracy, to people being able to contradict hegemony and to be self-correcting. And that can be done when people feel secure, when scientists and researchers feel secure, in economic sense, in a psychological sense, in a social sense. So I think that's the best way of doing that.
Thank you very much. Just one addition to this from a bit different angle. I'm a sociologist dealing mostly with the institutions. For years, I lived during the Polish transformation from communist to post-communist. I believed that maybe our civil society is not that strong, but we succeeded in building real strong, stable, resilient, democratic institutions. And then in 2015, Jarosław Kaczyński came to power, and just like that, overnight, he devastates many of the democratically elected and built institutions. And on the contrary, civil society is becoming stronger and stronger, organizing various forms and protests and mobilizations, which finally in 2023 brings the opposition, I mean Donald Tusk's party, into power. So I think that despite the role of the institutions and all legal provisions, solidarity and civil society activities, these are also very important mechanisms. And now I know that Emilia wants to add something, please. And,
yes.
but let's leave some time for most questions.
I will be
It
very
was just
short.
one question. Keep it in mind.
It was a great question. That's why we all want to answer. So you were asking why we are not speaking about legislation, regulation, and so on. Who makes the legislation? No, not me. It's the members of the parliament. Yes, it's the government. It's not the scientists. So you want to see the members of the parliament and the government to prepare a legislation that will give autonomy to us? No, this is not their goal. This is what they fight against. Some of us here, you, professor, keynote speaker, myself, we have been in the black hole. So maybe more of us should go there, because only then we can influence the policy making, because there are not so many scientists in politics, and this is a big, big issue. So maybe we need a party of scientists. I believe that this will help Europe. So I said that I'm done with politics, but if there is a party of scientists, I would be happy to join it.
That's not the case in Poland. You know, in Poland we have some scientists in politics, but usually these are historians, and they are usually right-wing historians.
And I have one objection
not physicists.
I have one objection to the party of scientists. It means that if we get even 10% of votes, it means that the trust in science falls to this 10%. So very risky.
Okay, please ask. Yes, please go ahead.
I will just give a very brief comment on Rudy's idea and democracy. That I think a very like a critical and analytical view on the processes of democracy is also important, because democracy as such, it's another field of challenges and problems. And I think if this is not in a way predicted and we don't dive into this, we are much more vulnerable. Now the question, first of all, trust and belief and the gaps that we leave into the process of creating trust. That's one of the questions, because trust isn't blindly accepting something, but it needs something more. And closely related to this is vulnerability. If we talk about avoiding vulnerability, my question is, isn't there already a deeply ingrained contradiction? Because novelty as such always brings vulnerability. So how do you see this relationship?
Thank you very much. Would like to reply? Maybe you... Yes, please go ahead.
Is this one working? I'm going to use an example. So it's not maybe exactly what you were asking, but it might get everyone else thinking as well. So being a publisher or representing the publishing community, it's probably no secret that not everybody wants to talk positively about publishers. And there's this narrative out there that publishers and libraries and publishers and institutions and publishers and researchers are at best in conflict, and at worst we're enemies, right? And this is certainly the case in the United States. There's been quite a bit of a tension. But when things suddenly started shifting in the United States, there was a coming together of all of us at this higher level and saying, whoa, we've been taking a lot of things for granted. We need to think about what matters right now, and we need to work together. But the interesting thing, to your point of trust, the big question we've been tackling in the United States too is, what's happening to trust in science? That's a collective thing that we need to address. But one of the things we discovered was first we had to build trust among ourselves and to demonstrate what that looked like. To your point too, there was a process there, right? We needed to get vulnerable. We had to begin to be able to say, how might we first have a conversation and talk about some of those? Let's first put aside some of the really difficult issues, and then let's come back and first in closed doors start to talk about some of those more difficult issues so that we do trust each other and we can though have those conversations more publicly. So it's been an interesting process for us of how we also bring our communities together, because I think for us, so I would just say that on that trust point, I think to ensure that we maintain trust, we also need to think about how do we work together as these different communities, because we have that collective interest in ensuring that, yes, there is going to be resilient, long-lasting trust in science. What is that going to take? But we also have to trust each other, because otherwise we're just seeding distrust of the entire system outside of it, right? So that's not quite what you were asking, I know, but I just wanted to at least bring in one bit of the trust puzzle that I've been looking at and been involved with in recent times. My hope also is that we've seen other organizations here in Europe reach out to the alliance that we've brought together, Alliance with a small a, because some boards didn't want us to have Alliance with a big A. So Alliance with a small a, but saying, how could we help? We could see that things could happen also here in Europe, or there's been risks, so how do we support that?
Thank you very much. We still have time for one question. Please.
Yeah, I wanted to bring one point in, because we've been talking about the resilience of the system. And then I was wondering whether we should look at the people that are in the system, whether those are the ultimate protectors of that resilience. And I don't want to sound too negative, because I'm aware we have a privileged position. We are academics. We are able to generate knowledge. We have a lot of freedom in our work. But I think quite a lot of people that are in the system, they're not in love by the system, because the system does not potentiate their skills, their ability, their freedom. And I think, looking at ourselves, there's still a lot to be done in terms of improving the academic system, improving the leadership within academia, so that people are more likely to go into the black hole to defend the system. Because I see a lot of inner criticism towards the system, and I think that's also something that is in the way of the resilience that we want.
I believe that basically we agree with this remark. So I would like to thank all panelists and to the audience. And there is one thing which came to my mind, which we haven't addressed yet today. Maybe it's for the future. I see the paradoxical situation that we are living in the era of rationality, growing rationality, actually continuously facing also growing simultaneously irrationality, which was specifically visible during the pandemic, when people were not prepared to understand how science is functioning, and they consider the debates among scientists as the sign of the weakness of the science, and which generated the distrust to science. So my question would be, to what extent these are external factors responsible for this growing irrationality, various interest groups which might be interested in widespreading their irrationality among nations and societies, or to what extent this is our internal research community inability to communicate about science to the broader public. I think that at least the second thing, we might be thinking about controlling, at least to some extent, because we cannot stop, various interest groups from widespreading irrationality, but we can communicate better our achievements, I think, including what happened during COVID pandemic. So again, thank you very, very much.
So, thank you also from my side to our panelists and all the inputs, our attentive audience. A discussion wouldn't be anything without your questions. And for all the food of thought we have gathered this afternoon. And I think we can leave this discussion with the feeling that we are all ambassadors. In the end of the day, as you just said, we have to communicate what science and research is about, every single one of us. And I hope we can do this and start with it, continue the discussion in the next coffee break. And we have postponed it a little bit so that it won't be too short. But we would like to continue with the Madame de Staël Prize ceremony at 16:45 sharp. And it would be great if you could have that time in mind, but we would also gather you again after the coffee break. Thank you.
ask people to come in. It's dangerous, I would say, but or maybe. But it's okay. May I have your attention, please? Ladies and gentlemen, distinguished guests, it's a great pleasure to welcome you to today's ceremony at which we present the ALLEA Madame de Staël Prize, one of Europe's most prestigious distinctions awarded by ALLEA. The prize honors scholars whose work has not only achieved academic excellence, but has also helped to strengthen European values, intellectual freedom, dialogue across borders, and the courage to speak across political and cultural divides. The prize bears the name of Madame de Staël, a remarkable thinker, writer, and a public intellectual of the early 19th century. She was renowned for her independence of mind, her resistance to authoritarian power, and her deep belief that Europe is held together not by force, but by ideas, culture, and exchange. It is especially meaningful to present this award here in Poland. Just to mention, in 1812, fleeing Napoleon's growing hostility, Madame de Staël undertook a dramatic journey from war-torn Europe to Russia, passing through the lands of the former Polish-Lithuanian Commonwealth. She carefully observed Polish society and landscapes, attentive to both the scars of political loss and the resilience of civic culture. These impressions informed her later reflections and strengthened her conviction that the Polish experience was inseparable from the broader European story. Her seminal work, in English it's simply Germany, played a crucial role in shaping the understanding of Romanticism along the banks of the Vistula, influencing generations of Polish intellectuals. and her personal ties to Poland were equally striking. Madame de Staël became the godmother of Zygmunt Krasiński, one of the greatest voices of Polish Romantic literature. The values embodied by Madame de Staël, intellectual courage, independence of thought, and a deep sense of responsibility for the public role of scholarship, are not confined to her own era. They live on in scholars who combine scientific excellence with moral clarity and civic engagement. It is therefore a particular honor that the laudation for today's award will be delivered by Professor Christiane Nussland-Volhard. Her career exemplifies the very qualities Madame de Staël stood for: intellectual rigor, openness across disciplines, and the courage to speak out for the values of science and society alike. Christiane Nussland-Volhard is a German developmental biologist, Nobel Prize laureate, whose groundbreaking research transformed our understanding of the genetic control of embryonic development. She holds a special place in history as the 6th woman ever to receive this honor. I now have the great pleasure of giving the floor to Professor Nussland-Volhard, who will present laudation for this year's laureate, Professor Marie Leptin, a distinguished molecular biologist and the president of the European Research Council, internationally recognized for the contributions to science and to strengthening excellence in European research, and let me add, a friend of all of us in ALLEA. Professor Nussland-Volhard, the floor is yours, please.
Good evening, ladies and gentlemen. It is a great pleasure and honor to introduce Professor Maria Leptin as recipient for the Madame de Staël Prize of the European Federation of Academies of Science and Humanities, ALLEA. First of all, I congratulate you for the choice of this laureate. You could not have done better. Maria Leptin is, Maria Leptin is outstanding as one of the rare people who combine excellent research with invaluable service for the scientific community. I first met Maria when she applied as a junior group leader at our institute, the Max Planck Institute for Developmental Biology in Tübingen, in 1989. She had studied biology and mathematics in Heidelberg and done her thesis with Fritz Melchers at the Basel Institute for Immunology. As a postdoc, she radically changed fields and spent several years working on cell adhesion in Drosophila with Michael Wilcox at the famous Laboratory for Molecular Biology of the MRC Cambridge, and a shorter period of 3 months in the lab of Pat O'Farrell at the University of California in San Francisco. For her research as junior group leader in Tübingen, she chose to work on early development of the Drosophila embryo, gastrulation, a topic of her lab since that time. She ran a small group of 2 postdocs and 2 graduate students, and a talented technician with whom she produced the famous beautiful sections of ventral furrow formation, which made it on the cover of the journal Development and into several textbooks, and set the stage for her future research. As junior group leader in Tübingen, she had 2 children, while her husband, Jonathan Howard, resided and researched in the UK. At this time, 1991, very few female scientists had children, and no daycares existed. In Tübingen, together with another mother scientist, she founded the first daycare for small children in the Max Planck Society, called Plankton. This was a challenging and difficult task, as there was no prototype how such a facility could be set up and organized. At the same time, she established her own profile as an independent scientist. We watched with amazement, admiration, and sometimes concern for her health, but she did all her jobs in her own energetic and efficient way, and everything turned out well. Maria and her husband got settled as full professors at Cologne University, where she continued her studies on Drosophila developmental genetics. After a short stay as visiting professor at the École Normale Supérieure in Paris in 2001, she spent a sabbatical at the Wellcome Trust Sanger Center in Hingston, UK, to get a training in genomics and bioinformatics. In the past 12 years, parallel to her lab in Cologne and her directorship at EMBO, she ran a research group at the EMBL. Maria Leptin's research has covered a large range of topics: immunology, cell biology, developmental genetics, morphogenesis, in which she made important discoveries manifested in a continuous stream of excellent publications. Her primary studies on Drosophila covered cell adhesion and the genetics and cell biology of gastrulation. In particular, she investigated the morphogenetic movements of mesoderm formation, which starts with the infolding of the mesodermal Anlage occurring at gastrulation. The Leptin lab identified several downstream effectors of the transcription factors twist and snail controlling this event. Her research on morphogenesis covered a wide range of sophisticated methods of genetic analysis, cell biology, microscopy, biophysics, and theoretical modeling. Her work also included the formation of the tracheae, respiratory organs of Drosophila, and epidermal wound healing. More recently, in her lab at the EMBL in Heidelberg, she took up research on zebrafish as animal model and worked on pathogen defense. Throughout her work is of exceptional technical and intellectual quality and originality. Maria and I collaborate on a non-scientific project since 2004, when we started a foundation to support young female researchers in situations similar to Maria's at the time. We support talented graduate students or postdocs with children with a stipend to buy extra time for research, for example, by freeing them from household chores by employing a cleaning lady. The financial support not only helped the women to bridge the difficult task of combining research with a family, but also gives them moral support to follow a career as a scientist. We help them along with the aim to convey to the students our own enthusiasm for science. We organize an annual get-together, which is highly appreciated as it helps exchanging experiences and building useful networks for the women. Already as group leader in Tübingen, Maria showed her talent in organizational matters and took an active and visible part in the Institute's programs. She was a wonderful colleague. Problems were dealt with in a rational manner, no fuss, no complaints, but practical reasoning coupled with exceptional, compared to others at the Institute, sense of responsibility for the place. Innovations did not frighten her. Difficulties were taken as challenges for creative solutions. In contrast to, admittedly, myself, she never got angry, out of spirits, or losing her temper, although her personal situation and workload at the time had been all but easy and relaxed. Perhaps these are the features I mostly admire in her: getting things done with discipline and reliability, her openness and enthusiasm while in perfect control of her emotions, and always respecting those of others. Maria Leptin has served the scientific community at several levels. As managing director at her genetics department at the University of Cologne, she organized the annual Cologne Spring Meetings. Further, she introduced a structured PhD program and became the founding dean of the first formal graduate school at Cologne University. This has developed under her leadership to the Graduate School of All Biological Sciences at the university. With her reliable judgment of quality of research and outstanding diplomatic talent, she has been and still is much run after member of all kinds of activities in science policy and administration, and served on numerous scientific advisory boards, selection panels, committees, and board of trustees. She also acted as one of the first chairs at a panel for the newly founded European Research Council, ERC. She has been involved in scientific publishing as editor of the journal Mechanism of Development and a member of editorial boards of several scientific journals. For 12 years, since 2010, until her appointment as president of the ERC recently, Maria Leptin has been director of EMBO, the European Molecular Biology Organization, situated in Heidelberg. EMBO is one of the oldest European scientific organizations, founded in the late 60s. Its most important programs are postdoctoral fellowships, an annual symposium, courses and workshops, a young investigator program, several high-impact scientific journals. To date, it has about 2,000 scientific members who had been elected over the years following a nomination procedure. Director of EMBO is a big, challenging job, and I, as a former Secretary General of EMBO, was very happy and proud to see how well this organization, which is of such fundamental importance to European life science, has been functioning while Maria Leptin was its director. Her contract had been twice renewed. We accept it as granted that the fellowship and workshop programs run smoothly and that biological science in Europe has a competent representative in EMBO. But only the few of us who have served on the committees and other organizational matters at EMBO can appreciate how much we owed to Maria's strong leadership. She started the EMBO Global Investigator Network, supporting talented young researchers to establish their labs in Chile, India, Japan, Singapore, or Taiwan. Under her direction, EMBO was the first organization to convert a high-level selective journal to open access. Further, EMBO has introduced a completely new mechanism of manuscript review common, to minimize publication delay due to repeated submissions. During her directorship, Maria led, in addition to her lab in Cologne, her own research group next door at the European Molecular Biology Labs, EMBL, which is one of the world's leading institutes in modern biology. This gave her the opportunity to work on a new field of pathogen defense in the zebrafish. As of October 2021, Maria Leptin is elected president of the European Research Council. The ERC has been founded in 2005 as a concerted effort of many European activities, among others EMBO and the EMBL. The ERC, set up by the European Union in 2007, is the premier European funding organization for excellent frontier research. It funds creative researchers of any nationality and age to run projects based across Europe. I have been one of the 22 pan-European members of its first scientific council. It is a big success story as it supports frontier, basic as well as applied research independently of political considerations, based solely on the profile of the principal investigator. Researchers apply to several grant schemes depending on research experience and scope. 4 attractive flexible grants for up to 5 years core grant scheme, starting grants, consolidator grants, advanced grants, and synergy grants in 3 main research domains: physical sciences and engineering, life science, and social science and humanities. The ERC's mission is to encourage the highest quality research in Europe through competitive funding and to support investigator-driven frontier research based on scientific excellence. The Scientific Council, with Maria Leptin as president and 3 vice presidents, has to establish the selection panels and the difficult tasks of guaranteeing a fair and just treatment of researchers of all countries of the EU and associated countries. The ERC business is run by an executive agency in charge of the day-to-day grant administration. One of Maria Leptin's first activities was to argue for a doubling of the budget of the ERC. In retrospect, a wise move, given the substantially increased numbers of excellent applications. There are many more excellent applications than can be funded. She is a tireless advocate for frontier research based on the excellence of the principal investigator, independent of political considerations such as nationality, gender, collaborations, age, etc. She fights in a continuous struggle to protect the ERC from unnecessary administrative rules of the European Commission and pleads for an independent implementation structure run by the Scientific Council instead of the Commission-dependent executive agency. This has in fact been the original plan when the ERC was founded, but still waits for implementation. But already during her leadership, several tedious and unnecessary bureaucratic measures of Brussels have been abandoned. A new grant scheme, ERC Plus grants with budgets up to 7 million euros and 7 years durations, will start in 2027. The ERC president is, unlike the directorship of EMBO, a full-time job, and Maria, with deep regret, had to close her research labs upon her appointment, which has recently been renewed. But she keeps in contact with present-day modern research as member of advisory boards of several international research institutions. Maria Leptin is member of EMBO, the Akademie Europaea, the German Akademie Leopoldina, the Berlin-Brandenburg Academy, the Royal Society, and the National Academy in the United States. She was awarded an honorary doctorate by the École Polytechnique Fédérale de Lausanne, the ETH Zurich, the University of Lisbon, and the University of Cambridge, UK. And now she will receive the Madame de Staël Prize of the European Federation of Academies of Science and Humanities, ALLEA, an award that honors researchers and intellectuals whose work has made a significant contribution to the further development of Europe. I would therefore like to congratulate not only for the choice of this laureate, but also you, Maria, on receiving this award.
So this is the award that you are receiving, and then the statue.
Whoa, it's heavy.
Yeah, it's heavy, so it's something for you to carry home. We have also a special diploma. That,
very nice,
that
beautiful.
You were awarded, and of course.
Oh.
Congratulations.
Thank you. Look. Thank you for matching it to my outfit.
Yeah, that works well. And now we'll ask you to deliver an acceptance speech.
Well, thank you. What an honor. Thank you all. Thank you, Pavel. Thank you, members of ALLEA, dear Yanni, colleagues and friends, full of gratitude. Yanni, thank you for that speech. I don't know whether most of what you say is true. You didn't make any factual mistakes, except maybe one. I didn't get angry. I kept my emotions under control. That's the first time I hear this. But, oh, compared to others, okay. Anyway, so it's always hard to give any speech at all after a day with such excellent contributions. Basically, everything that I have in my notes here has already been said by my colleagues and friends this afternoon. Even so, I have no choice but to go through them. Now, in accepting honors, people often say, I am humbled, when you can see that they're just bursting with pride. So I'll just say I'm very proud. And I'm also deeply honored to receive the Madame de Staël Prize. I'm also moved by it because this prize is not only recognition of work done, it's also a reminder of the kind of Europe many of us have spent our lives working in and working for. Madame de Staël, as we've just heard, was a towering intellect and an incisive thinker. I wish I were like that. I don't think that's me. I think I'm maybe more of a fighter, and my fight has been on behalf of the scientific community that I love and admire. And what a privilege it is to be among that community here with all your towering intellects, and you, the people who make up the members of the academies that are awarding this prize. it's in the face of that community that I do feel humility. I couldn't begin to compare myself, of course, with Madame de Staël, but I am hoping that I can live up to some of the ideals she represents, her virtues and her strengths. For example, in her strength in speaking up against authority. In her case, Napoleon, which is not quite like the authority that I have to speak up against. De Staël talks about loving her country, France. And she asks why, if she loves France, she shouldn't also be allowed to admire aspects of what is happening in literature in England and in Germany. And she concludes with a sentence, the chapter about the thinkers in Germany, how it is fine to admire them. A sentence that the censors later deleted from her manuscript, which was then pulped altogether, so was never even published, de l'Allemagne, as we just heard. What she says is, we need not, I imagine, wish to encircle the frontiers of literary France with a great wall of China, very topical, to prevent all exterior ideas from penetrating within. She continues, it is possible for a literature not to conform to our laws of good taste, as she calls it, and yet to contain new ideas which, modified after our manner, would tend to enrich us. So she says this about literature, but to me, it's very familiar, and it reminds me very much of some current political thinking on research, if in reverse. These are, of course, ideas that are anathema to scientists. Building walls is counterproductive, and it's what we've heard this afternoon, what I have been saying, and what she said 200 years ago. So I'm especially grateful to ALLEA for this honor because academies occupy such a special place in the scientific landscape. At their best, they give science a collective voice. They remind us that knowledge is not sustained only by individuals, but by institutions, standards, memory, and trust. And Yanni, I want to thank you again for your words. You know that science does not look as heroic from the insides as prizes suggest. Much of it looks like confusion, repetition, failed experiments, colleagues failing to understand what you're doing, and then the occasional moment when something suddenly makes sense. One thing we always have to keep in mind, of course, when receiving an individual prize is that science is not a solo performance. My own career has depended on teachers, lab members, colleagues, and friends who advised me when I was wrong. Again, that included you. And of course, any successful career also depends on conducive environments and freedom, as I agreed with the minister, the Under-Minister for Science, Stepczyk, here in Poland this morning. So I accept this prize with gratitude, also for the scientists with whom I've worked, the institutions that made the work possible, and the many people across Europe who defend the conditions in which the research can be done so well, which includes all of those you hear who are engaged in the necessary political work that this requires. And ALLEA has indeed been very supportive in the recent 12 months or so, also in the current situation in Europe. De Staël lived in a Europe of borders, court, censorship, ambition, exile, conversation. She moved through a world in which ideas were powerful enough to frighten rulers. Her salon was one of the places where public life was made. But she did not defend Europe as a uniform culture. She was interested in differences and diversity. She understood that Europe's strength was not that everybody had to agree, but quite the contrary, that people could argue across borders and still recognize one another as participants in shared intellectual life. And of course, science belongs exactly to that history. Long before the EU, there was already a European habit of intellectual exchange. It was called the Republic of Letters. It may not have been quite as democratic as the phrase suggests, It excluded many people. It was shaped by class, gender, money, empire, language. So I don't want to romanticize it. But even with all those limitations, the idea is important. Scholars wrote to one another across borders. They sent books, specimens, instruments, observations, and objections. They argued, they corrected and challenged each other, and they depended on one another. Actually, very topical here, there is a great description of aspects of that life by your local, meaning Polish, Nobel laureate Olga Tokarczuk. She describes part of this life in her beautiful language. Unfortunately, I can't read it in Polish, but she has a fantastic English translator. And she describes that in her book, Flights. And it's actually also very topical and very funny that she, of all people, has been accused this week of having abused her academic freedom in writing as a writer for using AI to inspire her and to help her in her research for her next novel. I find it totally amazing that her fellow literature stars have attacked her for that. Anyway, she's an independent thinker in the best in the best tradition, and I admire her tremendously. Back to the Republic of Letters, like I say, which she partly describes. That's still how science works. It's not letters so much today, but emails and Zoom calls and conferences. We've heard about the importance of them, but the underlying structure is the same. Science really relies on conversations across distance. It's not just a stock of facts. It's also a way of making claims vulnerable to correction by others. That's also one of the reasons why science has been such a powerful European ideal. Not that it belongs to Europe, it certainly doesn't, but science expresses something Europe has often aspired to be, a space where authority is not sufficient, but where argument matters, where evidence can travel, and where no single center has the final word. That's a fragile ideal. Europe has, of course, also produced dogma, exclusion, violence, persecution. Scientists in my own country, Germany, have certainly not always been on the right side of those ideals. So we mustn't speak about, so when we speak about science as a European ideal, it shouldn't be in self-praise, but as we should speak as having inherited something valuable, partly damaged and certainly unfinished. And that's also how I think about my own career in Europe. As Yanni said, I've been in Germany, Switzerland, Cambridge, France, spent time in the US, in the UK, and I've later worked in European organizations. None of these moves were sort of made as a statement about Europe or internationalism. They were just about following the work. And I'm sure we all, in our careers, simply followed the most exciting opportunities, went where the cutting edge work in our field was happening, went where there were inspiring leaders. Science has made it normal for us to belong to more than one place. And I think that's one of the reasons we're talking about internationality here today. It's a great gift. It's nice to remember how unusual that is, historically and politically, for somebody to cross borders simply because of curiosity, not because of exile like de Stael, not because of war or looking for work, but because the knowledge we seek is elsewhere and the system allows and indeed encourages us to go there. Moving country as a scientist is exciting, but it's also challenging. As group leaders, we see people arrive with incomplete language skills, ignorance of local customs. They must learn not only new methods, but also new ways of discussing, disagreeing, new assumptions about hierarchy, independence, responsibility, even new sense of humor. Science benefits from this discomfort, as I'm sure we're all aware. A lab where everybody has been trained in exactly the same way may be a smooth running machine, very efficient, but it can also be narrow, and it likely lacks the real resilience to respond respond to strong impacts, because as we've heard, resilience requires diversity. So international science is not valuable because it's always harmonious. It's valuable because it makes complacency harder, and it nurtures the diversity and therefore the resilience that we need to be useful for the future. It's generally recognized and seen as good policy in the many exchange programs, whether it's DAAD in Germany or the EMBO postdoctoral fellowships we heard about, or the wonderful Fulbright program from the US, and Trump messing around by that is surely symptomatic and counters everything we've talked about here today. But this brings me to the ERC. Of course, I don't want to turn an acceptance speech into an advertisement for the institution I currently serve as president for, but of course I can't leave out the ERC. The ERC, apart from everything that Yanni has said, is one of Europe's clearest expressions of trust in researchers. Its basic idea is simple: fund excellent researchers to pursue their best idea, wherever those ideas may take them. Don't ask them to prove in advance that they'll have impact. Don't pretend that we can know at the beginning which discoveries will matter most. But the ERC is not based on trust without judgment. It's based on peer review and competition, and the willingness of researchers to expose their ideas to demanding scrutiny. We ask, like many other organizations at national level and international level, we ask other scientists to judge whether a proposal is ambitious, grounded in expertise, and whether the person proposing it has the capacity to do it. That's a very European act in the best sense, and it combines freedom with standards. But science is also asked, quite rightly, to address all sorts of challenges: climate, health, security, competitiveness, regulations, to counter disinformation, to respond to emergencies, and to provide evidence for difficult political choices. Totally legitimate demands. Science is, after all, part of society and must not retreat into a private world. But if science is asked only to be useful in immediately recognizable ways, it will become less useful over time. This is one of the hardest messages to convey in policy discussions. People are not wrong to ask what public money achieves. We all have to justify that. But if we fund only what we already know that we value, we will only get more of what we already know. And Europe cannot afford that. Now, that's a long-term view, and again, that came up with the ministry this morning. And such a long-term view is difficult to defend in a short-term environment, and politics is a short-term environment. The politician wants to be re-elected in 2 years' time and doesn't care whether the science that they help funding now brings benefits in 10 years' time. So that's a dilemma. Political cycles are short, public attention moves quickly, as does this glass. Actually, I'll drink some. Good. And it's tempting to treat curiosity-driven research as a luxury that we can fund when all other problems have been solved. It's admirable, but it's secondary. I think we all agree that that's a mistake. Frontier research is not a luxury. It's one of the sources from which future practical possibilities come. We saw this in the pandemic. People did not begin in 2019 or 2020 to learn molecular biology or study RNA. The solutions for the pandemic drew on decades of work, done at a time when there was no pandemic application in view. Such visible breakthroughs often rest on long invisible history. AI is the other one. And AI was not invented when ChatGPT came out, but has been rigorously pursued since the middle of the last century. And Europe really has to be mature enough to invest in this invisible history and invest in the history today that will be the history of tomorrow. So we have to create the history for the future. And that's why academic freedom really matters. Science cannot do its work if researchers are allowed to ask only safe questions, fashionable questions, or questions that are approved ahead of time by political authority. Academic freedoms is sometimes misunderstood as a privilege claimed by academics for themselves in a selfish manner. I see it differently. Academic freedom is a condition that an enlightened society creates because society needs knowledge, and that includes knowledge it cannot predict. It's a way of protecting the future from limits of our present imagination, and it does this by being open to the geeks and the nerds and the eggheads in their ivory tower. Robbert, that was you. Who pursue ideas that we now don't understand. So that's the importance of academic freedom. It does not mean that researchers are beyond responsibility. Of course not. Freedom in science comes with duties. We've heard some of them: intellectual honesty, sharing of data, openness to correction, and care in the treatment of people, animals, data, and the environment. And it comes with tough training and a tough selection process. The freedom to pursue science unencumbered, or at least the privilege to have it funded, has to be earned. That brings us to careers. A career in science, I think most of us will agree. And by the way, when I say science, I use what is usually translated from the Germanic languages, Wissenschaft, which obviously includes the humanities and the social sciences. And in fact, one of the reasons for taking on the ERC presidency is that I was so happy to be in an environment where that was seen and cherished and honored. So, right. So a career in science, meaning a career in academic thinking, is wonderful, but it's also hard in ways that are not always visible from the outside. Research is hard because nature, or also thinking, is not obliged to make itself simple for us. It's just there, and it's up to us to crack it. The building blocks that Robbert mentioned this morning, he did them from the natural world: cells, molecules, organs, atoms, those building blocks, but also those from the social sciences, societies, ideas, languages, brains. They do not arrange themselves easily into neat work packages. So this leads to also insecurity, competition in scientific careers, moving, waiting, and the feeling that everyone else is more confident, more competent, and more strategic. Especially many young scientists believe that they are the only ones who are improvising. We all, of course, know otherwise. A great deal of science, if not all science, is done by people who are outwardly competent and inwardly uncertain. So we as more senior people have a responsibility to be truthful about that, and we have a responsibility not to make a career look smoother than it is. We should not discourage young people, but we should also not mislead them. The point is simply that science is not easy. It is, however, for many of us, and probably for all of us here, worth it. There is the intellectual difficulty, and that's actually part of the appeal. Research is worth it because there are moments when you see something nobody's seen before, discoveries in the natural sciences, or combined thoughts, or have a clarity about an idea that you didn't have before. That's a feeling that's difficult to explain to people outside research. It's that closer contact to reality that makes it so special. And I think that's why people enter scientific or research careers and stay in them. Now, of course, the demonstrations outside Parliament today has young people asking for fair salaries. And like you, I totally support that. We do have to have the conditions for these people who are willing to make sacrifices in terms of uncertainty about careers. Where does the next grant come from? But they should be rewarded at least with a minimum wage, and as I think as teachers and as risk takers, at least with an average wage at later stages. Okay, back to ALLEA and the academies. The event in which this prize is being awarded is and has today been framed around trust, integrity, resilience, academic freedom. These are not only abstract themes. They actually describe the conditions under which science can remain useful to society without becoming subordinate to every pressure placed upon it. Now, trust is not created by explanation alone. In fact, scientific mansplaining, I hate that term, women do it as well. Sounds better, mansplaining though, it is really probably counterproductive in most cases. Us eggheads explaining to those others, to the so-called man in the street, how science works is not the way to create trust in science. Trust is created by our own conduct, by admitting uncertainty, by correcting errors, by distinguishing evidence from opinion, by being clear about conflicts of interest, by not overstating, and certainly not overselling what we know and we can achieve. Mistakes were made also during the pandemic in that area, and that should be a lesson to us all. We all know that's not a weakness of science, that is the strength of science. Science is one of the few human systems that has built correction into its self-image. We take that for granted. Papers are challenged, experiments are repeated, theories are modified, and the authority of a speaker is not what is supposed to settle the matter. That is very different from politics. But that's exactly why science can serve democracy. Even though it in itself is not democratic in the simple sense, scientific claims are not decided by majority vote. They are decided by arguing and facts. But science and democracy both share a suspicion of unaccountable authority. They both depend on institutions that allow challenge as a matter of fact and not as a means of destruction. That's also, on the other hand, why authoritarian politics often has an uneasy relationship with independent research. Not because every scientific result is potentially political and convenient, but because the habits of science are inconvenient. Evidence, openness, criticism, including self-critique, international contact, loyalty to standards beyond the state. And we see how that is irking some people. It's also why the international nature of science matters so much now. We are seeing great geopolitical tensions, and it would be naive to pretend that science floats somehow above politics. Research can have security implications, technologies can be misused. But awareness of risk must not become a generalized suspicion of contact. The Americans have shown us how badly wrong it can go with their China initiative, and I'm hoping that Europe will put on the brake before putting in similarly destructive and unwise restraints. If we treat every international collaboration as a threat, we will damage the thing we are trying to protect. The answer is not innocence or naivete, but judgment. And Europe really has to find that balance. We must protect sensitive knowledge where necessary. We need to understand strategic dependencies, but we also need to defend the openness that, after all, makes science science. Madame de Staël knew something about intellectual life under pressure. She knew that ideas need places to gather and to grow. She knew that conversation can become political simply by remaining free. And she knew that exile is not only a punishment imposed on individuals, it is also a loss for the society that drives them away. All this has relevance today. Europe must remain a place where researchers at risk can continue their work. We've heard about Ukraine earlier today. Supporting them is not charity, it's solidarity, but also self-respect. If Europe claims to value academic freedom, then it must act when academic freedom is attacked. Europe has, of course, built institutions that try to make cross-border knowledge a normal part of public life. The ERC is one, ALLEA is another, CERN, we heard, is another example, and so are Europe's universities, academies, research infrastructures, learned societies, labs, and exchange programs. These institutions may not be perfect, they may be slow, bureaucratic, but they also protect something that would be very hard to rebuild if lost. And that's perhaps one of the most important points today. The conditions for good science are built slowly and patiently, but they can be damaged very quickly. If we want science to remain a foundational European ideal, we have to treat it as foundational in practice. That means investing in it. It means defending academic freedom, supporting excellence wherever it is found, while helping more places to build the conditions in which excellence can emerge. It means trusting researchers and also expecting high standards from them. It means taking the long view. And as I've said, it's difficult because the long view rarely wins a meeting, especially if it's a political meeting. The urgent issue wins, the crisis wins, the measurable, deliverable, horrible word, wins the meeting, and the long view sort of has to sit quietly at the end of the table and hope that someone will remember it. We must remember it. This does not mean we should abandon planning. It means we should be humble about prediction. Every serious scientist knows that reality is more inventive than we are. That's part of the fun. That's why we need curiosity, not as a charming personal quality, but as an organized principle of research. Curiosity says there is something here we don't understand, and that is sufficient reason to look for it. So let me end where I began, with gratitude. I'm grateful for this prize because it honors values that I care about: curiosity, independence, intellectual exchange, and a Europe made through conversation rather than command. Science will, of course, not solve every problem. Scientists should not pretend that. But science does give us one of the best ways we have of being less wrong together. And that's not a small thing. Thank you. Okay. I'll leave this here. Oh, do I take questions?
Thank you so much for this inspiring lecture. And I have to say we are proud. It's yet another flower. Yeah. We are indeed very proud to have you in this growing family of the awardees of ALLEA, and that's a great thing. You named yourself a fighter, and we support you in all those fights for the independence of ERC, and we will do it because it's also the fight for values. It is the fight for excellent science in Europe. You also mentioned in your lecture Olga Tokarczuk, which shows that science and culture goes together, and it is indeed an extremely good writer. So I encourage those of you who didn't have a chance to read anything of her. That's a great writer. But I'm mentioning it because I want to mention the culture, and we start to switch to another part of this evening. You can imagine that we're thinking how to finalize this ceremony, and usually when we think about Poland, you probably think that okay, they will play Chopin, and since we have young academies with us, already 8 young academies, young people, so we decided, so let's do something different. And we have with us a young band, Omasta, a jazz hip-hop fusion band from Kraków that blends jazz improvisation with hip-hop grooves and contemporary urban energy. Their music is vibrant, spontaneous and driven by deep rhythm and collective dialogue. And we are talking about various prizes, awards, so let me mention that Omasta has performed at leading venues and festivals across Europe, including the London Jazz Festival, OFF Festival, Gent Jazz Festival, the Jazz Café, and Ronnie Scott's in London, and as well as AB in Brussels. Each concert is a dynamic, one-of-a-kind experience that bridges genres and audiences. So this performance offers a powerful and inspiring close to the evening dedicated to ideas, dialogue, and cultural exchange. Join us for a concert full of groove, freedom, and creative intensity. Please start your show.